Hello, good evening everyone. This is Shambhavi, your physics master teacher. Welcome to Vedantu, Karnataka. How are you all? Hope my audio and video is visible. Let me also check here. And if you are there, kindly respond if my audio and video is clear. Yes, it is clear. How are you all? How is your preparation going on? Yes, if you are there, kindly respond in the chat box. How is your preparation going on? You might have done with your first internal test as well. Good evening, everyone. Yes, good evening. Good evening, Anita. How's your preparation going on? Is my audio and video is clear? Can you just let me know once? Yeah, it's fine. Okay. So, as you know, we are started with uh, a session or a batch for your NEET exam preparation, that is Mission MBBS. Okay, so every day you're going to have a class from 5 to 7 with the main goal to focus on NEET 2026. Hope you had a few sessions from the last Monday. Okay, so today we'll be starting with the physics, first session for your Mission MBBS. Okay, so as you know, in NEET we'll be having questions from both first PUC and second PUC, or you can say class 11 and class 12. So we will be taking up all the chapters. We'll be giving you some theory part, whatever the chapters deal with. Okay, so little bit of theory, important formulas, important concepts we will derive, followed by MCQs and some PYQs. Okay, so that's the main goal with this batch, that is Mission MBBS. So uh, in physics we'll be just going according to NCERT chapter wise, like units and measurement, then we can go to motion in a straight line, and in between we'll also take up class 12 topics, where we'll start from electrostatic, that is electric charges and fields, then potential and capacitor, like that we will go. Okay, so in NEET, you had to pay attention for chapters in class 11 as well as class 12. Okay, so both are equally important. Okay, so we had to focus on the chapters from both first PU and second PU, or class 11 and class 12. Okay, thanks for your response, Anita. Hope others are also following. You can just respond in the chat box so that I get to know that you're following the session, and it gives me motivation that I can straight away start ahead for concept discussion. Yes. Okay. So the point is, as I said, today we'll be discussing with the first chapter, that is units and measurements. Okay, in that I'll be mainly focusing about the units and then dimensions and significant figures for today, and in the next upcoming session we can go to something called as error and error analysis. Okay, we'll just go topic wise in each session. Okay, so coming to the topics that we'll be covering, as I said, units, dimensions of the physical quantity, and then dimensional analysis and its application, Then we will move on to significant figures. Okay, first we'll quickly discuss, the little bit of theory about all these units, dimensions, and how to solve certain problems depending on your dimensional analysis or application of dimensions, whatever you can say. And then we'll move on to MCQs. Okay, in which type MCQ can be framed from this chapters. So we'll solve MCQs as we go ahead with the session. Okay, so if you're following, quickly give me a thumbs up that I can go ahead for the chapter discussion. Yes, hello. Okay, Anita, thanks for reminding. Yeah, definitely I'll be using Kannada. Okay, and if at any point of time, if you find you're not able to follow, just drop a message in the chat box. I'll quickly, try to explain again in Kannada. Okay, so Kannada and English, I always, wish to have a session with equal importance with English and Kannada. But if at all, if I just suddenly go ahead with any one particular language, it may be English or Kannada, just remind me there. I'll quickly explain it to you in other way as well. Okay, yeah. Okay, yes. Yeah. Okay, then I hope that as a positive response, and I will go ahead with the topic. So as we said, first in the chapter units and dimension, what we essentially had to understand what is a physical quantity is. Okay, so physical quantity andre yenu. So anything that can be measurable. Okay, so we can able to measure and express with some numerical value. We call that as a physical quantity. Okay, so physics ಅಲ್ಲಿ ಏನು physical quantity ಅಂದ್ರೆ ನಮಗೆ ಅದನ್ನ measure ಮಾಡಕ್ ಆಗಬೇಕು and we should be able to express it in some proper numerical value. Okay, for example, I say what is the mass of some object, so we should be able to measure it something like 10 kg, 5 kg, whatever it is, right? So I can able to measure it and I can able to express that amount with some numerical value. Okay, so that is your physical quantity. So how do we express the physical quantity? That is Q is equals to N U anta baritivi. Okay, so heng baritivi, Q is equals to N U, where Q is some physical quantity. It may be anything. As we discuss, along, we will learn about n number of physical quantities. Okay, it can be any physical quantity. So it will be having some numerical value as n, and along with that it should require some unit. Okay, so then only it will be a meaningful measurement. So numerical value followed by the unit. So that is how we represent physical quantities. And I think quickly you can let me know certain physical quantities which you will come across in your daily life. ಹೇಳ್ತೀರಾ ಯಾವುದಾದ್ರೂ ಒಂದಷ್ಟು physical quantities ನಿಮಗೆ ಗೊತ್ತಿರೋದು? Can someone try in the chat box? So let it be little bit of interactive session. So then only it will be helpful for your competitive exam preparation. So you should quickly respond. Yeah. Can you just let me know some physical quantities? Anybody who is watching? Yeah. Yes, length, mass, time, force, energy. Yes, very good. Okay, so we can list like length, mass, time, force, energy, temperature, current, the weight, and then force. Yeah, so many quantities, heat, energy, and then we have something called as temperature. So any physical quantity you can label. So they are all, we know how to measure, we know how to express, and we also know what are the units of them. Okay, so expression of a physical quantity means its numerical value followed by unit. Okay, so that we know very well. So now we derive the, or we classify the physical quantities into two kinds. One is fundamental quantity, the other one is derived quantity. Okay, so ಎರಡು classification ಮಾಡ್ತೀವಿ, ಯಾವುದು fundamental quantity ಮತ್ತೆ derived quantity ಅಂತ. Yes, PS Kakkeri, right? Your name? Yeah. So yeah, thanks for your response as well. So fundamental quantities andre ಏನು? They are like very fundamental. You cannot able to express them in terms of any other physical quantity. Okay, so they are called as fundamental physical quantity, or you can say like independent quantities. Okay, they are, they are very independent. You cannot able to express it in terms of any other physical quantity. So derived quantity andre ಏನು? So exactly ulta bardre sari ಏನು? So e quantities na you can able to express in terms of other fundamental quantities. Okay, so which can be expressed in terms of fundamental quantities. Okay, the physical quantities which can be expressed in terms of fundamental quantities, we call it as derived quantity. Okay, hope it is clear. So next is unit. So as we said, if at all we are talking about expressing any physical quantity, what do we need? So we know to, we need to know measuring, how to measure it, and also we need to know how to express it with the proper unit. So ali unit andre no, it is the standard reference. Okay, standard universally accepted reference for any measurement. We call that as unit of that physical quantity. Okay, so the conventional quantity used as the standard of measurement. What is the fundamental reference unit? Okay, or fundamental reference measuring unit, we call it as unit. Okay, so again we will have two types of units, fundamental unit and derived unit. So fundamental unit andre no, the unit of fundamental physical quantity, we call it as fundamental units, and derived units andre no, the units of derived quantities, we call it as derived unit. Or you can also say like, yeah, the units of derived physical quantities, or these are the units which can be further written in terms of fundamental unit. Okay, so these are all certain very basic definition which you should know. Hope it is clear till here. Any doubt? Kindly let me know if doubts. Yeah. So next is system of units. Okay, so system of units andre ಏನು? So ಎಲ್ಲಾ ಯೂನಿಟ್ಸ್ ನ, ಓಕೆ, ಕಂಪ್ಲೀಟ್ ಸೆಟ್ ಆಫ್ ಯೂನಿಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಸೊ ಅದನ್ನ ನಾವು ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ಇಟ್ಸ್ ಲೈಕ್ some base units are there, or fundamental units are there, and some derived units are there. ಸೊ ಅದನ್ನೆಲ್ಲ ಟುಗೆದರ್ ಮಾಡಿ ಒಂದು ಕ್ಲಾಸ್ ಮಾಡಿದ್ರೆ ಅದೇನದು ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್. ಸೊ ಆ ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ ಅಲ್ಲಿ ಎಲ್ಲಾ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಯ ಯೂನಿಟ್ಸ್ ಇರುತ್ತೆ ಅಷ್ಟೇ. ಓಕೆ, ಸೊ ಕಂಪ್ಲೀಟ್ ಸೆಟ್ ಆಫ್ ಬೋತ್ ಬೇಸ್ ಯೂನಿಟ್ಸ್ and derived units is known as the system of units. So nimige some examples nimge gottide. So basic earlier used system of units. So can someone tell me, so what are the common system of units which were earlier used, and presently all over the world we have one commonly accepted system of unit ide. So that also we will discuss. Yes, Vanita, hello. Hope you are doing good, and hope your preparation is also going good. Yes. So ಯಾವ್ದು ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ಸ್ ಗೊತ್ತಿದೆ ನಿಮಗೆ? ಇಟ್ಸ್ ಲೈಕ್ CGS ಸಿಸ್ಟಮ್ ಅಂತ ಕೇಳಿರ್ಬೋದು, FPS ಸಿಸ್ಟಮ್ ಅಂತ ಕೇಳಿರ್ಬೋದು, MKS ಸಿಸ್ಟಮ್ ಅಂತ ಕೇಳಿರ್ಬೋದು. ಕರೆಕ್ಟ್? ಸೊ ಇದೆಲ್ಲ ಯಾವುದು? CGS ಅಂದ್ರೆ ಏನು? ಸೊ ಇಲ್ಲಿ ಏನ್ ಮಾಡಿರ್ತೀವಿ, ಸೊ ಲೆಂತ್. ಓಕೆ, ದೆನ್ ಇಫ್ ಐ ಸೇ ಮಾಸ್, ಟೈಮ್, ಇದು ಮೂರನ್ನ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿ ಅನ್ಕೊಂಡಿರ್ತೀವಿ. ಸೊ ಲೆಂತ್ ಈಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಸೆಂಟಿಮೀಟರ್ ಆಗಿರುತ್ತೆ, ಮಾಸ್ ಈಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಗ್ರಾಮ್ಸ್ ಆಗಿರುತ್ತೆ, ಟೈಮ್ ಈಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಸೆಕೆಂಡ್. ಅದನ್ನ ನಾವು CGS ಅಂತ ಕರಿತೀವಿ. ಎಸ್, ವೆರಿ ಗುಡ್. ಎಸ್ ಅನಿತಾ, ವೆರಿ ಗುಡ್. ನೆಕ್ಸ್ಟ್ ಯಾವ್ದಿದೆ? FPS. FPS ಅಲ್ಲಿ ಲೆಂತ್ ನ ಫೂಟ್, ಪೌಂಡ್, mass is measured in pound, and time is measured in second. Foot, pound and second ಆಗಿರುತ್ತೆ. Yeah, so it's a British unit. Okay, earlier it was widely used, and still in some European countries they follow all foot, pound, second system. Okay, and then we have MKS system. So what is this MKS system? Meter is to measure length, kg is to measure the mass and time is measured in second. Okay, FPS, CGS, MKS. The name itself will tell you what are the units for these three physical quantities. Okay, length, mass, time na basic or fundamental units anta accept ಮಾಡ್ಕೊಂಡಿರ್ತಾರೆ. So ಅದಕ್ಕೆ corresponding ಆಗಿರೋ unit ಮೇಲೆ we have three different system of units. But ಈಗ ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ ನಾವು? Yeah, so that is international system of unit. Okay, international system of units. So this is internationally accepted one. So wherever you go, it will be same everywhere. If I say mass is measured in kg in this system, everywhere it is measured in kg, and the standard reference unit, okay, that will also be same, which is accepted by International Bureau of Weights and Measurement. Okay, so simple again karitivi SI unit anta karitivi, International System of Units na SI unit anta karitivi. So ee SI unit alli eshtu fundamental quantity ide? Can someone tell me how many fundamental quantities are there in this SI system? I hope you know that there are 7 fundamental quantities or base quantities and 2 supplementary quantities irutte. Adikke corresponding agi 7 base unit irutte and 2 supplementary units irutte. So basic quantities yavadu anta first nodona, and then we'll learn about their units as well. So 7 basic unit yavadu? Mass, length, yavadu? Mass, length, time, temperature, current, luminous intensity, and amount of substance. Okay, so they are the 7 fundamental physical quantity. Adakke corresponding unit barita hodre, so mass is measured in kg. So there is slight issue with the pen tab, so the words may appear little elongated and slanted. Let me check with the next session what it is. Okay, so for now just try to adjust with this. So mass is measured in kg, length is measured in meter, time is measured in seconds, temperature is measured in Kelvin. So Kelvin in heng baritivi? Capital K. Okay, Kelvin is capital K. Then we have current, which is measured in something called as ampere. Notation is capital A. Okay, next luminous intensity, which is measured in candela. Okay, so notation eno? CD. CD is the notation for luminous intensity. And then amount of substance measured in moles, symbol ಏನು ಯೂಸ್ ಮಾಡಬೇಕು? MOL, mole. Okay, so ಎರಡು supplementary unit ಇದೆ, ಯಾವ್ದದು? Angle ಮತ್ತೆ solid angle. Angle is measured in radians, whereas solid angle is measured in steradians. Symbol RAD, rad for radians, and solid angle yavadu? Steradian, symbol SR. So these are the 7 fundamental units, followed by their 7 fundamental quantities and their fundamental units, followed by 2 supplementary units, that is radians and steradians. Okay, so e quantities bit bere in yavade physical quantity idru SI system alli naavu adana derived quantity anta tagotivi, and our quantity na we can able to express in terms of these basic quantities. Okay, hope it is clear till here. Any doubt? If any doubt, please respond in the chat box. Okay, yeah, going ahead. So then we have something called as, let me just tell you what is this plane angle and solid angle. So plane angle gottide nimge, yeah, so the angle between 2 lines, correct? So angle between 2 lines, or you can also imagine like the basic definition comes from the fact that if you draw a circle. So circle draw ಮಾಡಿದ್ರೆ ಅಲ್ಲೇನಾಗಿರುತ್ತೆ, ಸೊ ಒಂದು ಆರ್ಕ್ ಪೋರ್ಷನ್ ನ ತಗೊಂಡ್ರೆ, okay, so this is my arc portion, okay, and this is the radius, this is the center, this is the arc length ds ಅಂತ ತಗೊಂಡ್ರೆ, so ಇಲ್ಲಿ ಏನ್ ಆಂಗಲ್ ಇದೆ ಅಲ್ಲ, angle subtended at the center, so that we call it as d theta, which is ds by r ಅಂತ ಬರೀತೀವಿ. is the ratio of arc length to the radius. So ಅದನ್ನ angle or plane angle ಅಂತ ಕರಿತೀವಿ. It is a 2 dimension, right? Plane angle ಅಂದ್ರೆ this is in 2 dimension, okay, and unit ಏನಂತ ಹೇಳಿದೆ, radians. symbol ಏನು, rad. symbol is rad. So please remember, radian is the SI unit for angle and not degree. Degree is a convenient unit. ನಾವು ಅದನ್ನ ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀವಿ ಡಿಗ್ರೀಸ್ ನ, ಬಟ್ ಡಿಗ್ರಿ is not the SI unit. So conversion factor ಏನು, radians to degree ಅಂದ್ರೆ, so you can take like 2 pi radian ಅಂದ್ರೆ ಎಷ್ಟು ಆಂಗಲ್ ಆಗುತ್ತೆ, 360 degree, or we can say pi radians is equals to 180 degree. Okay, so this is the conversion factor. You can stick with pi radians is equals to 180 degree. Okay, or 1 degree ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, pi by 180 radians ಆಗುತ್ತೆ. Okay, so ಈ conversion factor ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. Is that clear? Any doubt? Yeah, any doubts? Please ask in the chat box. If no doubts, please give me a thumbs up in the chat box so that I can go ahead. And if you are understanding and liking the session, please like the session as well. And also, if you are new to the channel, please subscribe to Vedantu Karnataka channel. Okay? Yeah. Okay. Next is solid angle. The name itself will tell you it's a angle in 3 dimension. Okay? So just circle it to 2 dimension andre. So 3 dimensional equivalent of circle ಏನು, sphere ತಗೋಬೇಕು ನೀವು. Okay? So sphere ತಗೊಂಡು ಅಲ್ಲಿಯ surface area ಏನ್ ಬರುತ್ತೆ, ಸೊ ಅದನ್ನ ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ. Okay, so this is the surface area. ಇದನ್ನ center of the sphere ಅನ್ಕೊಳ್ಳಿ. Okay? Yeah? So ಆ sphere ಅಲ್ಲಿ if we take this as our radius, okay, so what is the area, okay, what is the area that has been covered when I rotate about this point O? Okay, so that surface area to the radius square, okay, so we call that as solid angle. So definition nodidre, the ratio of the intercepted area dA of the spherical surface described about the apex O as center to the square of its radius. ಹೇಗೆ ಬರಿಬಹುದು, so omega is the notation, so small angle ಇದ್ರೆ d omega ಅಂತ ತಗೊಳ್ಳಿ. So d omega is the solid angle, it is the ratio of area, okay, so the area to the square of the radius, r square. Okay, hope it is clear. Yeah, dA by r square. D omega is dA by r square. So idu imagination bandilla andre just take the example of a cone. Okay, so cone alli enagirutte, you can imagine like your ice cream cone. So enagirutte, yeah, I try to draw it. Yeah, so illi enagirutte, so this is our apex or center or the vertex of the cone ಆಗಿರುತ್ತೆ, correct? So ಇದನ್ನ ನಾನು ರೇಡಿಯಸ್ ಅಂತ ತಗೊಳ್ಬಹುದು. So this will be the surface area which is described by this radius r. So ಅದೇ ತರ ನೀವು ರೇಡಿಯಸ್ ನ ಜಾಸ್ತಿ ಅಥವಾ ಕಡಿಮೆ ಮಾಡ್ತಾ ಹೋದಂಗು ಸರ್ಫೇಸ್ ಏರಿಯಾ ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಅಥವಾ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಕಾರ್ಡಿಂಗ್ಲಿ, ರೈಟ್? ಸೊ ಇಲ್ಲಿ ತನಕ ನಾನು ರೇಡಿಯಸ್ ಅಂತ ತಗೊಂಡ್ರೆ ದಿಸ್ ವಿಲ್ ಬಿ ದಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ. ಓಕೆ, ಆ ರೇಡಿಯಸ್ ಇನ್ನೂ ಜಾಸ್ತಿ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, ಸರ್ಫೇಸ್ ಏರಿಯಾ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಇಸ್ ವಾಟ್ is the solid angle inside the cone. Okay, yeah, is that clear? Or you can imagine, like, I hope you can see this if I show like this. So just imagine this as the radius and this holding point as the center or apex O. So ಇದನ್ನ ಒಂದ್ ಸತಿ ಹೀಗೆ ರೊಟೇಟ್ ಮಾಡಿ 3 dimensional. ಸೊ ಏನ್ ಏರಿಯಾನ್ ಕವರ್ ಮಾಡುತ್ತಲ್ಲ, ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ದಿ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಬೈ ದಿ ಸ್ಕ್ವೇರ್ ಆಫ್ ದಿಸ್ ಲೆಂತ್, ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಯು ದ ಸಾಲಿಡ್ ಆಂಗಲ್. ಓಕೆ, ಸೊ ಹಿಂಗೆ ಇಟ್ಕೊಂಡಾಗ ಇಲ್ಲಿ ಏನ್ ಆಂಗಲ್ ಕವರ್ ಮಾಡುತ್ತೆ ನೋಡಿ ರೊಟೇಟ್ ಮಾಡಿದಾಗ, ಸೊ ದಟ್ ಇಸ್ ಅವರ್ ಸಾಲಿಡ್ ಆಂಗಲ್. ಓಕೆ, ಹೋಪ್ ಯು ಗಾಟ್ ದ ವಿಜುವಲೈಸೇಷನ್ ಆಫ್ ಇಟ್. ಅಂಡ್ ಯೂನಿಟ್ ಇಲ್ಲ ಇದೆ ಏನು, ಸ್ಟೆರೇಡಿಯನ್ ಸಿಂಬಲ್ ಏನು, SR, represented by SR. Okay, is that clear till here? Any doubt, or shall we go ahead? If it is clear, give me a thumbs up, so I'll just go ahead. Okay, hope there are no doubts in these basic quantities and supplementary quantities and their units. Okay, so careful agire unit baribekare ಒಂದು ಪಾಯಿಂಟ್ ಏನು, ಸೈಂಟಿಸ್ಟ್ ನೇಮ್ ಇದ್ರೆ, ಲೈಕ್ ಇಲ್ಲಿ ಕೆಲ್ವಿನ್ ಇದೆ, ಇಲ್ಲಿ ಆಂಪಿಯರ್ ಇದೆ, ಸೊ ನೀವು ಸಿಂಬಲ್ ಬರಿಬೇಕಾದ್ರೆ ಕ್ಯಾಪಿಟಲ್ಲೇ ಬರಿಬೇಕು, ಕ್ಯಾಪಿಟಲ್ ಕೆ ಕ್ಯಾಪಿಟಲ್ ಎ. ಓಕೆ, ಸಿಂಬಲ್ ಆಫ್ ದ ಯೂನಿಟ್ ಏನು, ಕೆಲ್ವಿನ್ ಅಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ ಕೆ ಅಲ್ವಾ, ಅದ್ರ ಸಿಂಬಲ್ ಕೆ. ಆಂಪಿಯರ್ ಅಂದ್ರೆ ಎ ಇಸ್ ದಿ ಸಿಂಬಲ್, ಕ್ಯಾಪಿಟಲ್ ಲೆಟರೇ ಬರಿಬೇಕು. ಅದೇ ನೀವು ಫುಲ್ ಯೂನಿಟ್ ಬರೆದ್ರೆ ಆ ಎನ ಸ್ಮಾಲ್ ಲೆಟರ್ ಅಲ್ಲೇ ಬರಿಬೇಕು, ಅಥವಾ ಇಲ್ಲಿ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಈ ಕೆ ಸ್ಮಾಲ್ ಲೆಟರ್ ಬರ್ದಿದ್ದೀನಿ ನಾನು. ಹೋಪ್ ಯು ಹ್ಯಾವ್ ನೋಟಿಸ್ಡ್ ಇಟ್. ಓಕೆ, just to distinguish between the scientist name and the unit. So full scientist name onne ನೀವು ಬರಿತಾ ಇದ್ರೆ unit ಆಗಿ, so you had to write the first letter small letter. Okay, ಇಲ್ಲ ಅಂದ್ರೆ symbol ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅದು ಯಾವಾಗಲೂ capital letter ಇರಬೇಕು. Okay, so that is one small thing which will be following as a convention. Hope it is clear. Okay, I think I can go ahead. I have got few thumbs up there. So next is dimensions, which is the very important concept of today's session, that is dimension. So most of the time one or two question, one question will be there on dimension, or some questions will be there where we indirectly apply all these properties of dimension. Okay, yakandre kelavu MCQ na you can solve by cross checking for their dimensions. ಓಕೆ, ಕೆಲವೊಂದನ್ನ ಎಲ್ಲ ಕ್ವೆಶನ್ ಅಲ್ಲ, ಕೆಲವೊಂದು ಕ್ವೆಶನ್ ನ ನೀವು ಆಪ್ಷನ್ ಚೆಕ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡೋ ತರ ಇದ್ರೆ, ಸೊ ನೀವು ಡೈಮೆನ್ಷನ್ ಚೆಕ್ ಮಾಡಿನೂ ಮಾಡ್ಬೋದು. ಈಗ ಫೈಂಡ್ ಔಟ್ ದಿ ಈಕ್ವೇಶನ್ ಫಾರ್ ಸಮಥಿಂಗ್ ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ ಅನ್ಕೊಳ್ಳಿ, ಸೊ ಆ ಈಕ್ವೇಶನ್ ನ ಡೈಮೆನ್ಷನ್ ಮ್ಯಾಚ್ ಮಾಡಿನೂ ಮಾಡ್ಬೋದು. ಓಕೆ, ಸೊ ಯು ಲರ್ನ್ ಆಲ್ ದೋಸ್ ಟ್ರಿಕ್ಸ್ ಇನ್ ದಿ ಅಪ್ಕಮಿಂಗ್ ಕ್ಲಾಸಸ್. ಸೊ ಡೈಮೆನ್ಷನ್ ಅಂದ್ರೇನು, ಇಟ್ ಇಸ್ ಯಾವುದೋ ಒಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಕೊಟ್ಟಿರ್ತಾರೆ, ನೀವು ಅದನ್ನ ಹೇಗೆ ಬರಿಬೇಕು, ವಿ ಹ್ಯಾಡ್ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪವರ್ಸ್ ಟು ವಿಚ್ the fundamental quantities has been raised. Okay, so ಯಾವುದೋ ಒಂದು ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟಿನ ನೀವು ಹೆಂಗ್ ಬರಿತಾ ಇರ್ತೀರಾ, ಟು ದಿ ಪವರ್ ಆಫ್ ಸಮ್ ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟಿ ತರ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀರಾ, ಅದನ್ನ ನಾವು ಡೈಮೆನ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಡ್ ಡೈಮೆನ್ಷನ್ ಬರಿಬೇಕಾದ್ರೆ ನಾವು ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ಸ್ ಒಳಗಡೆ ಬರಿಬೇಕು. ಓಕೆ, ಸೊ ದೇ ಆರ್ ಡಿನೋಟೆಡ್ ವಿತ್ ದಿ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್. ಅಂಡ್ ಡೈಮೆನ್ಷನಲ್ ಈಕ್ವೇಶನ್ ಅಂದ್ರೇನು, ಏನಿಲ್ಲ, ವಿ ವಿಲ್ ಬಿ ರೈಟಿಂಗ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಈಕ್ವೇಶನ್ ನೊಟೇಶನ್. ಈ ಕಡೆ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಇರುತ್ತೆ, ಈಕ್ವಲ್ಸ್ ಬರ್ಬಿಟ್ಟು ಈ ಕಡೆ ಅದರ ಡೈಮೆನ್ಷನ್ ಬರಿತೀವಿ. ಓಕೆ, an equation obtained by equating a physical quantity with its dimensional formula. ಓಕೆ, ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಜೊತೆ ಆ ಕ್ವಾಂಟಿಟಿನ ಬರೆದ್ರೆ ಅದನ್ನ ನಾವು ಡೈಮೆನ್ಷನಲ್ ಈಕ್ವೇಶನ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ, ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಸೊ ಈಗ ವಿಲ್ ಜಸ್ಟ್ ಗೋ ಬ್ಯಾಕ್ ಟು ದೀಸ್ 7 ಫಂಡಮೆಂಟಲ್ ಕ್ವಾಂಟಿಟೀಸ್. what I will do is, so the dimensional notation ಹೆಂಗ್ ಬರಿತೀವಿ, notation of mass is capital M, or I'll write on this side. So all these 7 fundamental quantities idre adara dimension notation eno. So for mass capital M inside the bracket, for length capital L, for time capital T, and then temperature capital K inside the bracket. Okay, current ಗೆ capital A ಬರಿತೀವಿ. Okay, sometimes in some book you may see the notation as I. For current dimensional notation ಏನ್ ಮಾಡಿರ್ತಾರೆ, square bracket inside that capital I ಬರೀತಾರೆ. luminous intensity ಅದಕ್ಕೆ CD ಅಂತಾನೆ ಬರೆಯೋದು. Okay, amount of substance, again other dimensional notation, mole. Okay, so ಆ symbol ನೇ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, is that clear? So ಇಲ್ಲಿ ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಇದೆ, that is angle and solid angle ಇದೆ. Do they have dimensions? Can someone let me know? Do angles and solid angles are going to have dimensions? Can someone respond in the chat box? Angles ಮತ್ತೆ solid angle ಗೆ dimension ಇದೆಯಾ? ಯೂನಿಟ್ ಇದೆ, ರೇಡಿಯನ್ಸ್ ಅಂಡ್ ಸ್ಟೆರೇಡಿಯನ್ಸ್ ಅಂತ ಗೊತ್ತಿದೆ. ಸೊ ಅದಕ್ಕೆ do we have the dimensions? Can someone respond? Let me I'm just waiting for your response in the chat box. Do the angles and solid angle, are they going to have any dimension? Can someone respond? Question ಅರ್ಥ ಆಗಿದೆ ಅನ್ಕೋತೀನಿ. Yes, very good. It is not going to have any dimension. Correct, Anita. Very good. I'm happy that you are still following from the beginning. So whoever is listening to this session, I suggest you to attend the session from the starting to the end. Okay. So aವಾಗ ನೀವು ಯಾವ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಮಿಸ್ ಮಾಡಲ್ಲ. If you are very comfortable with that topic, that's fine. Apart from that, I suggest you to attend the session from the starting to the end. Okay. Yes. So angle ಮತ್ತೆ solid angle ಗೆ dimensions ಇರಲ್ಲ. ಯಾಕೆ ಅಂದ್ರೆ, so it's just an example. We will have few more physical quantity which are going to be dimensionless. ಏನಾಗಿರುತ್ತೆ ಅಲ್ಲಿ, they are going to be the ratio of the same physical quantity ತರ ಆಗಿರುತ್ತೆ. ಕರೆಕ್ಟಾ? ಇಲ್ಲಿ ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡಿದೀವಿ, angle is defined as ds by r ಅಂತಿದೆ. ds ದು dimension is length by length ಆಗುತ್ತೆ. So it becomes dimensionless. Okay, so ಅದೇ ತರ ಸಾಲಿಡ್ ಆಂಗಲ್ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, ಸೊ dA by r square ಇದೆ. dA ಅಂದ್ರೆ ಏರಿಯಾ ಡೈಮೆನ್ಷನ್ ಏನಾಗಿರುತ್ತೆ, L square ಆಗುತ್ತೆ. r square ಡೈಮೆನ್ಷನ್ L square ಆಗುತ್ತೆ. ಸೊ L square by L square ಅಂದ್ರೆ ಇಟ್ ಬಿಕಮ್ dimensionless. ಸೊ ಆ ಪಾಯಿಂಟ್ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು. ಓಕೆ, ಯೂನಿಟ್ ಇದೆ, ಡೈಮೆನ್ಷನ್ ಇಲ್ಲ. Okay, amongst the given 4 options, which is going to have a dimension, which is going to have a unit but no dimension? So yadu, you have to check for the option like solid angle or plane angle, like that. Okay, so now let us try to get dimensions of some physical quantities. Okay, so we'll just begin with some basic quantities which we'll be using now and then. So I can say like ಯಾವ್ದು ತಗೊಳ್ಳೋಣ, ಫಸ್ಟ್ ವೆಲಾಸಿಟಿ ತಗೊಳ್ಳೋಣ. ಓಕೆ, ಹೋಪ್ ಯು ಅಗ್ರಿ ಇಟ್ಸ್ ಅ ಡಿರೈವ್ಡ್ ಕ್ವಾಂಟಿಟಿ. ಸೊ ಡೈಮೆನ್ಷನ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಹೇಗೆ ಬರಿಬೋದು, ವೆಲಾಸಿಟಿ ಇಸ್ ಲೈಕ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬೈ ಟೈಮ್ ಅಲ್ವಾ, ಗೊತ್ತು ನಮಗೆ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬೈ ಟೈಮ್. ಸೊ ಈದರ್ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ದಿ ಡೈಮೆನ್ಷನ್ ಬೈ ದೇರ್ ಫಾರ್ಮುಲಾ or by knowing their unit. Unit ಏನು velocity do meter per second, correct? So ಈಗ dimension ಏನು ಬರಿಬೋದು, L t minus 1, because displacement ಅಂದ್ರೆ it is nothing but has a dimension of length, time it has the dimension of time, so L t minus 1. Okay, so that's how we do. Next is what, acceleration. ಯಾವುದು, acceleration. So the dimension of acceleration, so in general ಬರೆದ್ರೆ acceleration ಅಂದ್ರೆ ಏನು ಹೇಳ್ಬೋದು, change in velocity, rate of change of velocity, like velocity by time ತರ ಅಲ್ವಾ. ಸೊ ಏನು ಹೇಳ್ಬೋದು ಆಗ, velocity dimension ನಮ್ಗೆ ಗೊತ್ತು LT minus 1 divided by T ಆಗುತ್ತೆ, which is going to give you LT minus 2. Hope you are following. Yeah. Yes, Anita. Very good. Next is we'll take a quantity like force. ಇದೆಲ್ಲ ಅಲ್ಲಿ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾನೆ ಇರ್ತೀವಿ, ಇವಾಗ ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದೀವಿ. ನೆಕ್ಸ್ಟ್ ನೀವೆಲ್ಲ ಡೈಮೆನ್ಷನ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರ್ಕೊಂತ ಹೋಗ್ತಿರ್ಬೇಕು. ಓಕೆ, ಸೊ ಫೋರ್ಸಿನ ಡೈಮೆನ್ಷನ್ ಹೆಂಗ್ ಬರೀಬಹುದು? Force is like mass into acceleration. So dimension ಬರೆದ್ರೆ m raised to 1 L T minus 2, because acceleration dimension ನಮ್ಗೆ ಗೊತ್ತಿದೆ L T minus 2. Okay, so force is mlt minus 2. Then we will have something called as momentum. Can someone try for the dimension of momentum? Yes, can someone try for the dimension of momentum? Momentum heng baritivi? It is the product of mass into velocity. I just had given you a hint. It's the product of mass into velocity. Can you try for the dimension of momentum? Yes, whoever is watching, can you just tell me the dimension of momentum? Anybody? Mass into velocity, hint is there. So it's just very simple. I think I can give it to you now. So mass is m, velocity is lt minus 1. Okay, so that is how you write the dimension of momentum. Next is work done. Either you should know the formula or you should know the unit. Okay, so work done andre heng baritivi? Work done W is equals to F dx, or force into displacement anta baritivi. So this will tell me that the dimension of work done, W anta tagoltini. So force andre eno? Mass into acceleration. This force can be written as m into a, so that will give me ml t minus 2 into displacement in a dimension enagirutte L. So this will give you m L square t minus 2. Okay, m L square t minus 2 is going to be the dimension of work done. Okay, so can someone tell me whether you're following and you got the dimension of work done? So next is energy. Energy, ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಬರ್ಕೊಂಬಿಡಿ. Any form of energy it can be. Any form of energy. Any form of energy ಅಂದ್ರೆ ಏನಿಲ್ಲ, according to the way I'm saying, any form of energy ಅಂದ್ರೆ ಯಾವ ತರದ್ದಾರು ತಗೊಳ್ಳಿ. ಲೈಕ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ತಗೊಳ್ಳಿ, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ತಗೊಳ್ಳಿ, kinetic energy, potential energy, heat energy, or some nuclear sorts of energy. ಯಾವ form of energy ನಾರು ಆಗಿರಲಿ, thermal energy. Okay, any form of energy, mechanical energy ಅಂತಿರಲಿ, ಏನಾರ ಕೊಡ್ಲಿ, energy is energy. Okay, and we know that energy is the ability to do work or capacity to do work, correct? And we know that energy ಮತ್ತೆ work done in a unit ಏನು? Joules ಅಲ್ವಾ? Work done and energy both have the units like joule. So let me write here, unit ಏನು? Joule, or capital J is the symbol, correct? So ಯೂನಿಟ್ ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ ಅದರ ಡೈಮೆನ್ಷನ್ ಸೇಮ್ ಇರಲೇಬೇಕು ಅಲ್ವಾ? ಯೂನಿಟ್ ಸೇಮ್ ಇದೆ ಅಂದ್ರೆ ಅದರ ಡೈಮೆನ್ಷನ್ ಸೇಮ್ ಇರಲೇಬೇಕು. ಸೊ ವಾಟ್ ಐ ಕ್ಯಾನ್ ಸೇ, ದ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಎನರ್ಜಿ ಈಸ್ ಆಲ್ಸೋ m L square t minus 2 ಆಗಿರುತ್ತೆ. ಓಕೆ, ಇದು ಹೆಂಗ್ ಬಂತು ಅಂತ ತೋರಿಸ್ಬೇಕು ಅಂದ್ರೆ, ಸೊ ಏನ್ ಮಾಡ್ಬೋದು, ಐ ವಿಲ್ ಜಸ್ಟ್ ಟೇಕ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಓಕೆ, ಸೊ ಏನ್ ಮಾಡ್ತೀನಿ, ಐ ವಿಲ್ ಟೇಕ್ kinetic energy. Just a second. Yeah, so kinetic energy heng baritira? Kinetic energy is half mv square anta baritira alva? So iga dimension of kinetic energy beku andre half is just a number, so dimension iralla. Mass ina dimension capital M baribodu. V square andrenu LT minus 1 whole square ಅಂತ ಬರಿಬೋದು, which is going to give me together ಆಗಿ ಬರೆದ್ರೆ ಏನು ಬರಿಬೋದು, M L square T minus 2. Okay, so this is how you can say that energy also have the dimension like M L square T minus 2. Hope it is clear. Any doubt? Yeah, I think you, Anita, has responded for force, I guess. Okay, yeah, I think you have responded for the dimension of force. Yeah, I hope it is clear till here, and I think we can go ahead. We are good to go ahead, I feel. Any doubts? Kindly respond. Okay. If it is clear till here, give me a thumbs up in the chat box, or you can also like this session. And if you are new to the channel, please subscribe to our channel. Okay. So the next important property of the dimension. Okay. So I have given certain physical quantities. Okay. The dimension of certain physical quantities. You can also try for a few more physical quantities on your own, to write down the dimension. The point is, I just have taken very, few basic parameters, just because if some of you are still studying in class 11 or first PUC, you might not be knowing the physical quantities which I will be talking. So I just don't want you to, put you in confusion, because as you go ahead with the, with this first PUC or class 11, you learn many new physical quantities. Okay, so now your job is to, whenever you find some new physical quantity, your first job should be to get the dimension of that physical quantity. Okay, so some quantities I'll give you, so try to get the dimensions. I mean, you can take this as a homework part. Okay, so yeah, the quantities, I'll give you something like impulse, and then something like torque. Okay, and then I'll say gravitational force. Okay, I have given you gravitational force, not gravitational constant, because in many books there will be, you will be asked about the dimensions of gravitational constant as well. So I am asking you a gravitational force dimension, which you can easily tell. Okay, force is a force, that you remember, that is the hint. Okay, and yeah, if you are studying in second PUC or class 12, you can try to get the dimension of something called as capacitor, resistor, okay, and then potential. Okay, so try to get the dimensions of this 3 parameter. Okay, hope it is clear. Yes, I think we are good to go ahead. So that is principle of homogeneity of dimensions. So principle of homogeneity andre enu, it is the very basic factor of any physical quantities, I can say. So we can add or subtract the quantities which are having the same dimension. That is what is our principle of homogeneity. It's very simple, that I can add time to time, I can add length to length, mass to mass, energy to energy, force to force, momentum to momentum. There is no meaning in adding mass to length. I say there is 2 kg of mass and there is some 10-second time there. If I ask you to add them, does it going to give us any physical, meaningful physical quantity? Mass plus time madadre ಏನು ಬರುತ್ತೆ? ಏನು ಬರಲ್ಲ. It is not at all a physically measurable quantity or any, the valid physical quantity in physics, right? Mass and time ಗೆ add ಮಾಡಿದ್ರೆ ಏನು ಬರಲ್ಲ, ಅದು ಏನು ಅಲ್ಲ ಅದು, correct? So that is what is the principle of homogeneity is about. We can add mass to mass. I can add 10 kg plus 5 kg and I know it is going to give me still mass, as 15 kg, correct? Then I can say 5 Newton is there, 3 Newton is there in the same direction, correct? I should put a condition because they are vectors as well, then only I can add them directly, or else I should consider the angle between them. When we are talking about vectors, you will get into it. So 5 Newton plus 3 Newton, force and force, if I add, I get force. I'm not going to get something like time, right? Yeah. So with respect to addition and subtraction, that is very important. We can add or subtract the quantities which are having the same dimension. Okay, hope it is clear. Okay, so ಇದನ್ನ ಇನ್ನೊಂತರ ಏನು ಸ್ಟೇಟ್ ಮಾಡ್ತಾರೆ, the dimensions of all terms on either side of a equation must be same. So ಯಾವುದೋ ಒಂದು ಫಿಸಿಕಲಿ ಮೀನಿಂಗ್ಫುಲ್ ಇಕ್ವೇಶನ್ ಇದ್ರೆ ಅದು ಕರೆಕ್ಟ್ ಇದ್ರೆ ಏನಾಗಿರ್ಬೇಕು, the dimension on left hand side should be same as the dimension on right hand side ಆಗಿರ್ಬೇಕು. Okay, so that is what is your principle of homogeneity. So if I have a symbol like addition or subtraction or equals to, so ಆ ಮೂರ್ symbol ಇದ್ರೆ ಏನರ್ಥ, yeah, the dimension that are involved in that particular equation are same. So I can add the quantities which are having the same dimension, I can subtract the quantities which are having the same dimension. And if I'm saying something is equal to something, correct? So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾ ಇದೀನಿ, 10 plus 5 equals to 15 kg ಅಂದ್ರೆ I'm saying this much of mass is equals to 15 kg ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ, correct? ಅಂದ್ರೆ mass 15 kg is also a mass, correct? So that is also having the same dimension. It's a very intuitive, very basic principle of physical quantities. Okay, yeah, hope it is clear and we can go ahead, I feel. So next is applications of dimensions, which is very important. There are three major applications which we'll be discussing. One is to check the correctness of an equation, that we call it as dimensional consistency. We can only check the dimensional consistency. Okay, there can be still some equation which are dimensionally true, but physics wise it might be wrong. Okay, so because of various reasons, because 2-3 physical quantities are may going to have the same dimension. Okay, so ಎರಡು ಮೂರು physical quantity can have the same dimension. Okay, but it is possible, whether it is dimensionally correct or not, we can check. If some equation is dimensionally incorrect andre ಮುಗಿತು ಆ equation anyway ತಪ್ಪು ಅಂತ ಅರ್ಥ. ಹಂಗಂತ if it is dimensionally correct ಅಂದ ಮಾತ್ರಕ್ಕೆ it need not to be 100% correct equation. Dimensionally correct but 100% correct ಅಂತ ಹೇಳಕ್ ಆಗಲ್ಲ. We need to do other method. But ತಪ್ಪಿದೆಯಾ ಅಂತ we can find out. If the equation is wrong, we can check out. Dimensional consistency ಇದ್ರೆ fine, it is correct. Dimensional consistency ನೇ ಇಲ್ಲ ಅಂದ್ರೆ ನೀವು ಅದನ್ನ further check ಮಾಡೋದೇ ಬೇಡ. The other one is to derive the relation. Andre you can obtain the formula, you can derive some type of formula, not everything. Certain formulas can be derived by using the dimensional method. The other is to convert, unit in one system to other system. Okay, unit of a physical quantity from one system of unit to the other system of unit. Okay, like ಯಾವುದೋ ಒಂದು physical parameter na unit SI system ಅಲ್ಲಿ ಇದೆ, ಸೊ ಅದರ CGS ಏನು, ಆರ್ MKS ಅಲ್ಲಿ ಇದೆ ಅದರ CGS ಏನು. ಓಕೆ, ಆ ತರ ಡಿಫ್ರೆಂಟ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ಗೆ ಹೌ ಟು ಕನ್ವರ್ಟ್ ದಿ ಯೂನಿಟ್. ಸೊ ದಟ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಬಿ ಡನ್ ಬೈ dimensional analysis. Okay, hope it is clear till here and you're following as well. Any doubt? Okay, I consider there's a positive response and you're following as well. Kindly respond in the chat box. Okay, so the point is, in an equation, first one, I mean, we are considering the first application of dimensional analysis, that is to check the correctness of an equation. So when the equation correct agirbeku andre enu, it should follow the principle of homogeneity. That means the dimension of the quantity on either side must be same. Andre left hand side, right hand side same irbeku, and the terms which are separated by plus and minus iruttala madhyadalli adara dimensions same irbeku. Okay, just because As I said, I can add mass to mass, time to time, length to length, velocity to velocity. I cannot add acceleration to velocity, correct? It is not at all going to give you some meaningful physical parameter. But multiplication and division is allowed. Only with respect to addition, subtraction, we had to be careful. Okay, so illon simple, very well known equation ide yadu v square is equals to u square plus 2ax antide with our usual notation from your kinematics. Okay, so this is v square is final velocity, u is initial velocity, a is acceleration, x is displacement. So ಈಗ ಇದು ಕರೆಕ್ಟ್ ಇದೆಯಾ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. Okay, so we know that the dimension of velocity ಏನು lt minus 1 ಅಲ್ವಾ. ಅದೇ ತರ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಆಕ್ಸಿಲರೇಷನ್ ಏನು lt minus 2. ಓಕೆ, ಸೊ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರಿಬೇಕಾದ್ರೆ ಒಂದು ಸಿಂಪಲ್ ಸಜೆಷನ್ ಇಫ್ ಯು ಆರ್ ರೈಟಿಂಗ್ ದ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಸ್. ಓಕೆ, ಸೊ ಏನಾಗಿರ್ಬೇಕು, ಡೈಮೆನ್ಷನ್ಸ್ ಬರಿಬೇಕಾದ್ರೆ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಹಾಕಿ. ಓಕೆ, ಸೊ ಬ್ರಾಕೆಟ್ ಬರಿದೇ ಇದ್ರೆ ಮಾರ್ಕ್ಸ್ ಬರಲ್ಲ. ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಬದಲು ಬೇರೆ ಬ್ರಾಕೆಟ್ ನಂಗೆ ಇಷ್ಟ ಅಂತ ಫ್ಲವರ್ ಬ್ರಾಕೆಟ್ ಹಾಕ್ತೀನಿ, ಇನ್ಯಾವುದೋ ಬ್ರಾಕೆಟ್ ಹಾಕ್ತೀನಿ ಅಂದ್ರು ಇಟ್ ಇಸ್ ನಾಟ್ ಅ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅಕ್ಸೆಪ್ಟೆಡ್ ಮೆಥಡ್. ಸೊ ಡೈಮೆನ್ಷನ್ಸ್ ಬರೀತಿದ್ದೀರಾ ಅಂದ್ರೆ ಇಟ್ ಮಸ್ಟ್ ಬಿ ಇನ್ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ನೊಟೇಷನ್. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಯಾವ್ದು ಬೇಕು, ವಿ ಸ್ಕ್ವೇರ್ ಬೇಕು. ವಿ ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಎಲ್ ಟಿ ಮೈನಸ್ 1 whole square, which is nothing but L square t minus 2. ಅದೇ ತರ u square ದು ಸೇಮ್ ಇರುತ್ತೆ because that is also velocity. So I will write directly L square t minus 2 ನೇ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಯಾವ ಟರ್ಮ್ ಇದೆ, 2ax ಇದೆ. 2 is a number, no dimension. For 2, no dimension, it's just a number. Okay, but ax ಇದೆ, a into x, acceleration dimension lt minus 2 into x dimension L, which is going to give us L square t minus 2. So ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಏನಾಗಿದೆ, v square dimension L square t minus 2, u square dimension L square t minus 2, ax dimension ಏನು ಬಂದಿದೆ L square t minus 2, and I hope you agree with me that it is dimensionally correct. ಹೇಳ್ಬೋದಾ, dimensionally correct. And this is a correct equation also, we know it, right? You might have derived this also, so it's physically correct also. It's a correct or exact equation. Okay, no other correction needs to be done. It is dimensionally true also and a proper exact equation as well. So ಈ ತರ consistency na check ಮಾಡಬಹುದು ನೀವು. This is one application. Hope it is clear. Shall we go ahead? Yeah, any doubt, please let me know in the chat box. If you interact in the session, it becomes, the session will become even more interesting. And it will also become much more effective for you as well. Okay? So try to interact in the session. Yeah. So this is already I told you. If equation fails this consistency test, it is proved wrong. Dimensional consistency na obey madilla andre the equation is wrong. But if it passes, it is not proved right. Dimensional consistency ide and matrakadu correct agirbeku antilla. So dimensionally correct equation need not to be the actual equation. Okay, but a dimensionally wrong or incorrect equation is anyway going to be a wrong equation. Hope it is clear. Yes, so it's a very simple fact. We'll move ahead. The second application of dimension, that is to derive the force for centripetal force. I mean derive the expression for centripetal force. ಇಲ್ಲಿ ಏನಾಗಿರ್ಬೇಕು, ನೀವು ಯಾವುದಾದ್ರೂ if you are trying to obtain the expression or to derive the equation for some physical quantity, let me say I have some physical quantity, I should know on, I should assume that it depends on certain physical parameter. Okay, it depends on some parameters like P1, P2, whatever it may be. Okay, so like that I will assume Okay, and then only I can derive it. And I can also tell you, if the equation is going to depend on 3 parameters or 3 physical quantities, then only we can use dimensional method. ಮೂರಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ರೆ ಡೈಮೆನ್ಷನಲ್ ಮೆಥಡ್ ಇಂದ ನಿಮಗೆ ಈಕ್ವೇಶನ್ ಡಿರೈವ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಓಕೆ, ಸೊ ಇಲ್ಲೇನು ಅಸ್ಯೂಮ್ ಮಾಡಿದೀವಿ, ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಡಿಪೆಂಡ್ ಆನ್ ಮಾಸ್, ವೆಲಾಸಿಟಿ ಅಂಡ್ ರೇಡಿಯಸ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿದೀವಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಸೊ ಏನ್ ಮಾಡ್ತೀವಿ, we have a parameter, physical quantity. I want to obtain the expression by assuming it is going to depend on certain physical parameters. ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿನೇ ನೀವು ಡಿರೈವ್ ಮಾಡೋದು. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಫೋರ್ಸ್ ಇದೆ. ಫಸ್ಟ್ ಫೋರ್ಸಿನ ಡೈಮೆನ್ಷನ್ ಬರ್ಕೊಂಡ್ಬಿಡಿ. ನಮಗೆ ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿಯ ಈಕ್ವೇಶನ್ ಬೇಕೋ ಅದರ ಡೈಮೆನ್ಷನ್ ಬರೀರಿ. ಫೋರ್ಸಿಗೇನು ml t-2. Okay, so ega I can say this force, okay, let us assume force is going to depend, or I'll say initially proportionality is going to depend on mass raised to power x. I don't know what is this x. Mass mele depend agide, we'll look into it what exactly it is. And then velocity mele depend agide anta tagondidvi, let us say y, and radius raised to power z. Okay, or ಇದನ್ನ ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಏನು, f is equals to some constant, let me take it as some c, okay, m raised to x, v raised to y, r raised to z. So this is one of the limit of the dimensional analysis also I can say. ಏನದು, ಸೊ ಈ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ನಾನು ಹೇಳಕ್ ಆಗಲ್ಲ ಡೈಮೆನ್ಷನಲ್ ಮೆಥಡ್ ಇಂದ. what is that constant that is appearing in equation, we are not going to get by the dimensional analysis. Okay, but we can still get the dependency on other physical parameters. Dimensionless constant or the proportionality constant ಯಾವ್ದು ಬರುತ್ತೆ equation ಅಲ್ಲಿ, so ಅದರ ವ್ಯಾಲ್ಯೂ ನ ನಾವು ಡಿರೈವ್ ಮಾಡಕ್ ಆಗಲ್ಲ. that is one of the limitation of your dimensional analysis. Okay, so ಈಗ ಏನ್ ಹೇಳ್ಬೋದು, the dimension of force will be equal to, so a constant bittidini because it has no dimension, so I can say m raised to x. Okay, one step I'll write in detail, v raised to y and r raised to z. So next page alle barad bidtini, eno force ina dimension bariri, as we have already given, ml t-2 is equals to mass in a dimension m irutte, raised to x anta ತಗೊಂಡಿದೀವಿ. Okay, m raised to x. velocity dimension ಏನು, l t-1 raised to power y, and then ಯಾವುದು ಇರೋದು radius, ಅದರ dimension ಏನು, length raised to power z. Okay, so this is how we write. Next ಏನ್ ಮಾಡೋಣ, we'll just arrange them mlt separately. Okay, mass term ಒಂದ್ ಕಡೆ, length ಒಂದ್ ಕಡೆ, time ಒಂದ್ ಕಡೆ ಬರೆಯೋಣ. so mass ಒಂದರಲ್ಲೇ ಇದೆ, so it is still just like m raised to x. l ಇದೆ, l raised to y ಇದೆ, l raised to z ಇದೆ, so I can say l raised to y plus z and t raised to minus y. Okay, so t ಒಂದೇ ಟರ್ಮ್ ಇದೆ. ಈಗ ಏನ್ ಮಾಡ್ಬೋದು, so if the bases are same we can equate the powers. so ಇಲ್ಲಿ mass ಇದೆ, ಇಲ್ಲಿ mass ಇದೆ, ಇಲ್ಲಿ x ಇದೆ, ಇಲ್ಲಿ ಏನಿದೆ m raised to 1 ಇದೆ, so I can clearly say x is equals to 1. next, so ಏನಿದೆ ಇಲ್ಲಿ l raised to 1 ತರ ಇಲ್ಲಿ l raised to y plus z ಇದೆ, ಅಂದ್ರೆ ಏನ್ ಈಕ್ವೇಟ್ ಮಾಡ್ಬೋದು, y plus z is equals to 1 ಅಂತ ಬರಿಬೋದು. so still ನಂಗೆ y and z ಎರಡು ಗೊತ್ತಿಲ್ಲ, but you will get to know in a while. so next, which color shall I take? yeah, so ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ t raised to -2 ಇದೆ, ಇಲ್ಲಿ t raised to -y ಇದೆ, so ಏನಾಗುತ್ತೆ, I can say yeah, minus y is equals to, negative sign bidbedi, minus y is equals to -2, or this will tell you y is equals to +2. okay, so y is equals to +2 anta bantu andre So now I can say y plus z is equals to 1. But y ಗೆ 2 ಅಂತ substitute ಮಾಡಿದ್ರೆ 2 plus z is equals to 1, or this will give you z is equals to minus 1. Z value ಏನು ಬರುತ್ತೆ? Minus 1. Hope it is clear till here. So one last step. We are left with one last step. If you're following, just give me a thumbs up in the chat box, or you can respond that you understood, so that I can go ahead. So ಏನು ಬರಿಬೋದು ಈಗ? Force F is equals to m raised to x ಅಂತ ತಗೊಂಡಿದ್ವಿ ಅಲ್ವಾ, some constant into m raised to x, then we had velocity raised to y and r raised to z ಅಂತ ತಗೊಂಡಿದ್ವಿ. ಈಗ x y z ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. m raised to x ಅಂದ್ರೆ ಏನು ಬಂತು ನಮಗೆ? 1. v raised to y ಅಂದ್ರೆ 2 ಬಂದಿದೆ, and r raised to z ಅಂದ್ರೆ -1 ಬಂದಿದೆ. Or we can say f is equals to ಏನು ಹೇಳ್ಬೋದು? c into, so I can just rewrite like mv square by r. So r raised to -1 ಅಂದ್ರೆ ಅದನ್ನ ನಾನು ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಬರೆದಿದ್ದೀನಿ ಅಷ್ಟೇ. ಓಕೆ, ಸೊ ದಟ್ r raised to +1 ಆಗುತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ. ಸೊ ಏನಾಗುತ್ತೆ? f is equals to mv square by r into some constant, and here c will be equal to 1. This you will know by experiment method or any other method you should do, which will give you force as mv square by r. This is just for your information. So dimensionally nimga c value al bandiralla. Okay, but please remember the expression for centripetal force, which you may derive in maybe in laws of motion or the work energy power chapter. Okay, so centripetal force equation ಏನು ಬರೀತೀರಾ, or motion in a plane ಅಲ್ಲೇ derive ಮಾಡ್ತೀರಾ ನೀವು. Okay, centripetal force is mv square by r. Okay, a constant value 1 anta any other experiment should tell you, or any other different method you should use to get the value of constant. Okay, so ನನಗೆ ಗೊತ್ತಿರೋದ್ರಿಂದ I'm just saying c is equals to 1 ಅಂತ ತಗೊಂತಾ ಇದೀನಿ. It need not to be in all the case. Okay, is that clear? Any doubt? Any doubt? Please feel free to ask. So one simple homework ಕೊಡ್ತೀನಿ, similar one. Okay, easy ಇದೆ, easy ಕೊಡ್ತೀನಿ. So time of fall find out ಮಾಡಿ. Just imagine there's a stone, okay, which is dropped from some height. Okay, so it is dropped from height. This is our ground reference. Okay, ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ? Okay, the stone, how much time it takes to reach the ground, ಅದಕ್ಕೊಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬೇಕು. ಸರಿನಾ? ಟ್ರೈ ಮಾಡ್ತೀರಾ? Time to reach the ground. Okay, so ಅದಕ್ಕೊಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬೇಕು. Let us call the time of fall as something like t, and let us assume this is going to depend on mass, acceleration due to gravity, okay, mass, acceleration due to gravity and height h. ಸೊ ಈ ಮೂರು ಕ್ವಾಂಟಿಟಿ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿ. ಓಕೆ, ಸೊ what you should do by assuming, let me just make it little neat. Okay, so what we had done, so this is the height h. Okay, we have dropped a stone or a ball from some height h. Now I want to find you to get an expression for the time of fall by assuming that this time of fall depends on mass, acceleration due to gravity, that is small g. Okay, and height h ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅನ್ಕೊಂಡು. So try to get an expression for this. Okay, it's a small homework for you. Hope you will try it out and hope you can respond in the chat box. Yeah, if you are there, you can respond in the chat box. Yes. So the next application, if I come across, that is conversion of physical unit from one system to other system of unit. Okay, so unit na ಒಂದು ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ ಇಂದ ಇನ್ನೊಂದು ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ ಗೆ ಹೆಂಗ್ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು ಅಂತ. ಸೊ ಇದಕ್ಕೆ ಒಂದು ಸಿಂಪಲ್ ಮೆಥಡ್ ಇದೆ, ಯು ಜಸ್ಟ್ ಫಾಲೋ ದಟ್. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಯಾವ್ದು ತಗೊಂಡಿದೀವಿ, 1 ನ್ಯೂಟನ್ ಇಂಟು ಡೈನಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸೊ 1 ನ್ಯೂಟನ್ is equals to how much in dyne. Okay, so illi dyne is the CGS unit. CGS unit of force. Okay, CGS unit of force is dyne. So idakke en madana, we know that whatever may be the system of unit, okay, I am following, the measured quantities are same, right? ಸೊ ಏನ್ ಹೇಳ್ಬೋದು, ಕ್ವಾಂಟಿಟಿ ಸೇಮ್. ಈಗ ಇಲ್ಲಿ ಒಂದು 10 kg ಮಾಸ್ ಇದೆ ಅಂದ್ರೆ, ಓಕೆ, ಸೊ ನನಗೆ SI ಸಿಸ್ಟಮ್ ಬೇಡ, ಐ ವಿಲ್ ಗೋ ಫಾರ್ CGS ಅಂದ್ರೆ ಇದರ ಕ್ವಾಂಟಿಟಿ ರಿಮೈನ್ಸ್ ದಿ ಸೇಮ್ ಅಲ್ವಾ, ಬಟ್ ಅದರ ನ್ಯೂಮೆರಿಕಲ್ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಕ್ವಾಂಟಿಟಿ 10 kg ಇರುತ್ತೆ. ಜಸ್ಟ್ ಬಿಕಾಸ್ ಐ ಆಮ್ ಮೆಜರಿಂಗ್ ಇನ್ ಡಿಫರೆಂಟ್ ಯೂನಿಟ್, ಇಟ್ ಡಸಂಟ್ ಮೀನ್ ದಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಇಸ್ ಚೇಂಜಿಂಗ್. ಓಕೆ, ದಿಸ್ 10 kg ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಏನಂತ ಹೇಳ್ಬೋದು, 10 into 10 power 3 grams ಅಂತ ಹೇಳ್ಬೋದು. ಓಕೆ, ಸೊ ನ್ಯೂಮೆರಿಕಲ್ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ that fact we can write it as a formula. So please take down, that is N1 U1 will be equal to N2 U2, or more precisely ಅಂದ್ರೆ ಇದಕ್ಕೆ ಬ್ರಾಕೆಟ್ ಹಾಕಿ ಬರ್ಕೊಳ್ಳಿ, ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್, that is dimension ಅಂತ. So N1 andre numerical value in first system. Okay, let me first give it to you like this. N1 U1 numerical value in first unit, N2 is the numerical value in the second system of unit, U2 is the unit in the second system of unit. So e formula ನೆನಪಿಟ್ಕೊಳ್ಳಿ. From here let us say N1 ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, I'll say 1. Unit ಯಾವುದು, Newton. This is U1. Okay, dyne is U2. ಓಕೆ, ಸೊ ಇದು ನಮಗೆ ಗೊತ್ತಿರಬೇಕು. N2 ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ ಹೇಳಿದ್ದಾರೆ. ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ವಿ ಆರ್ ಫೈಂಡಿಂಗ್ ಔಟ್. N2 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ N2 ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು N1 ಇಂಟು U1 ಬೈ U2 ಅಂತ ಬರಿಬೋದು. ಸೊ ವೇರ್ ದಿಸ್ U1 ಅಂಡ್ U2 ಯು ಹ್ಯಾಡ್ ಟು ರೈಟ್ ಇಟ್ ಇನ್ ದಿ ಡೈಮೆನ್ಷನಲ್ ನೋಟೇಶನ್. ಏನ್ ಮಾಡಬೇಕು, ಡೈಮೆನ್ಷನಲ್ ನೋಟೇಶನ್ ಅಲ್ಲಿ ಬರಿಬೇಕು. ಹೆಂಗ್ ಬರಿತೀವಿ, ಸೊ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಫೋರ್ಸ್. ಓಕೆ, ಐ ವಿಲ್ ರೈಟ್ ಹಿಯರ್ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಫೋರ್ಸ್ ಏನು, MLT minus 2. So you just need to say N2 is equals to N1 into U1 ಅಂದ್ರೆ ಫಸ್ಟ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್. ಸೊ ಇಲ್ಲಿ SI ಇದೆ, M1 L1 T1 ರೈಸ್ ಟು -2 ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ U2 ಅಂದ್ರೆ ಏನು, ಸೆಕೆಂಡ್ ಸಿಸ್ಟಮ್. ಅಲ್ಲಿ ಡೈಮೆನ್ಷನ್ ಹೆಂಗ್ ಬರಿಬಹುದು, M2 L2 T2 ರೈಸ್ ಟು -2. Okay, where M1 L1 T1 represents the unit or the basic unit in first system, M2 L2 T2 represents the basic unit in the second system ಆಗಿರುತ್ತೆ. ಈಗ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಸೊ ಹೆಂಗೆ, N2 is equals to, ಸೊ N1 ಅಂದ್ರೆ 1 ಡೈನ್ ಇರೋದಲ್ಲಿ, ಸೊ 1 ಇಂಟು, ಓಕೆ, M1 ಅಂದ್ರೆ ಏನು, kg ಅಲ್ವಾ. In the SI system mass is measured in kg, and then we have L1 andre it is measured in meter, kg meter second minus 2 whole divided by M2 andre mass is measured in grams in CGS system, ಗ್ರಾಮ್ಸ್. L2 ಅಂದ್ರೆ ಏನು? ದಿಸ್ ಇಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಸೆಂಟಿಮೀಟರ್. ಅಲ್ಲಿ ಯಾವ ಬೇಸಿಕ್ ಯೂನಿಟ್ ಆರ್ ಫಂಡಮೆಂಟಲ್ ರೆಫರೆನ್ಸ್ ಯೂನಿಟ್ ಆಗಿ ತಗೊಂಡಿರ್ತಾರೆ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಟೈಮ್ ಈಸ್ ಎನಿವೇ measured in seconds in both the system, so it is simply second minus 2. Okay, so mlt minus 2 ಇದೆಲ್ಲ ಅದಕ್ಕೆ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಯೂನಿಟ್ ನ ಬರ್ತಿದ್ದೀನಿ. kg meter second minus 2, gram centimeter second minus 2, or we just need to convert it now. So kg ಅಂದ್ರೆ ಏನು ಬರಿಬಹುದು? 10 power 3 grams ಅಂತ ಬರಿಬಹುದು. Correct, because I know 1 kg is nothing but equal to 1000 grams. 1000 can be written as 10 power 3, that is like kilo. 10 power 3 grams. Meter andre enu? 1 meter is equals to 100 centimeter. Hope you agree. These are all very basic. So ಏನು ಬರಿಬಹುದು ಇಲ್ಲಿ? 100 ಅಂದ್ರೆ 10 power 2 ಅಂತ ಬರಿತೀನಿ. 10 power 2 meters. Okay, second minus 2 ಇಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಬಿಡೋಣ, ಎರಡರಲ್ಲೂ ಸೇಮ್ ಯೂನಿಟ್ ಇದೆ. So this second minus 2 and this second minus 2 will cancel out. So remaining terms baradre ಏನು ಬರುತ್ತೆ ನಮಗೆ? whole divided by gram centimeter. ಈಗ ಅಲ್ಲಿ ಗ್ರಾಮ್ ಸೆಂಟಿಮೀಟರ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಳ್ಬೋದಾ? ಯಾ, ಮೇಲ್ಗಡೆ ಒಂದು ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ. ಏನು? ದಿಸ್ ಇಸ್ 10 power 2 centimeter. So we already have converted that, right? So 10 power 2 centimeter, right? 1 meter ಇಲ್ಲಿ ಬರೀ ಕೆಜಿ ಬಂದ್ರೆ 1 kg 1 meter ಅಂತ ಅರ್ಥ ಅದು. Okay, so 1 meter is 10 power 2 centimeter. So this centimeter will go away. So ಏನು ಉಳಿಯುತ್ತೆ ನಿಮಗೆ? 10 power 3 into 10 power 2, which is nothing but equal to 10 power 5. N2 value 10 power 5. That means 1 Newton is equals to 10 power 5 joule ಅಂತ ಬರಿತೀವಿ. Okay, 1 Newton is equals to 10 power 5 joules. Hope it is clear till here. Any doubt? Yes? Any doubt? Kindly respond in the chat box if you're following, and if you have some doubts or if you understood everything, please give me a thumbs up and respond in the chat box, which gives us some motivation to go ahead. Yes? Okay, so what we will do is we will take a short break. Just a minute, I'll just let you know about the limitations of dimensional analysis, then we'll take a short break for 5 minutes and then we'll go ahead with the problems. Okay, so that is limitations of dimensional method. So which I have already told you, this can only useful, can only check the dimensional validity, but it is not going to tell you whether the the given relationship is an exact or the correct equation. That is one dimension, limits of dimensional method. The other one is dimensionless constant cannot be obtained by this method. So ಯಾವುದೋ ಒಂದು ಫಾರ್ಮುಲಾದಲ್ಲಿ dimensionless constant or proportionality constant ಇರುತ್ತೆ. ಸೊ ಅದು ನಮಗೆ ಈ ಡೈಮೆನ್ಷನಲ್ ಮೆಥಡ್ ಇಂದ ಗೊತ್ತಾಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಆ ನಂಬರ್ಸ್ ಗಳಿಗೆ ಡೈಮೆನ್ಷನ್ ಇರಲ್ಲ. ಯಾವುದೋ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಲೈಕ್ 4π ಬಂತು ಯಾವುದೋ ಒಂದು ಫಾರ್ಮುಲಾದಲ್ಲಿ. ಸೊ ಆ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ನ ವ್ಯಾಲ್ಯೂ we cannot determine by dimensional method in the formulas. Okay, and we cannot able to derive some equations like trigonometric, logarithmic, exponential functions. Okay, ಯಾವುದೋ ಒಂದು equation something like y is equals to a sin omega t, ಇದನ್ನ ನಾನು ಡಿರೈವ್ ಮಾಡಕ್ಕಾಗತ್ತಾ? ಆಗಲ್ಲ. ಯಾಕೆ? the trigonometric functions are dimensionless, logarithmic functions are dimensionless, exponential functions are dimensionless. ಯಾಕೆ? trigonometric function ಹೆಂಗ್ ಬರೀತೀರಾ? ratio of side lengths, right? ratio of the length ತರ, sin theta ಅಂದ್ರೆ ಏನು? opposite side by hypotenuse, ಎರಡರದ್ದು ಡೈಮೆನ್ಷನ್ ಸೇಮ್ ಇರುತ್ತೆ. Okay, logarithm we just put it, we apply to a number, correct? So pure numbers, trigonometric functions, logarithmic functions, exponential function ಅಂದ್ರೆ e ಅಂತ ಬರೀತಿರಲ್ಲ, yeah, so which you use in maths, they are all going to be dimensionless, and hence we cannot derive any equations which are involving this. And also ಯಾವುದೋ ಒಂದು equation ಈ ತರ ಇದೆ ನೋಡಿ, s is equals to ut plus half at square. ನಾವು ಇದನ್ನ ಡಿರೈವ್ ಮಾಡೋಕ್ಕಾಗತ್ತಾ? ಇಲ್ಲ. ಯಾಕೆ? ಎನಿ equations which are involving plus or minus, ಓಕೆ, ಅಡಿಷನ್ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಟರ್ಮ್ಸ್ ಇದ್ರೆ ಅದನ್ನು ಡಿರೈವ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಓಕೆ, ಅಡಿಷನ್ ಸಬ್ಟ್ರಾಕ್ಷನ್ ಟರ್ಮ್ಸ್ ಇದ್ರೂ ಡಿರೈವ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಓಕೆ, and then yeah, that point is here only. The addition subtraction terms idre ಆ equations ಅನ್ನು ಡಿರೈವ್ ಮಾಡಕ್ ಆಗಲ್ಲ. Okay, so these are certain limitations of the dimensional method. Okay, if no, but still at some cases it plays a important role and you can make use of that to derive some simple equations and to check whether the given equation is correct, or to convert unit from one system to other system. Okay, hope it is clear till here. And if you're following, let us just take a break for 5 minutes. Okay, be back by 6:21. Have a short break, 5 minutes. Okay, or I can say 6:21 p.m. Okay, so just come back by 5 minutes, take a short break. Yes, hope all of you are back from your break, a short break. If you come back, just give me a thumbs up. Yes. And my audio and video is also fine, I guess. It's fine here. Yeah. Hope video is also, audio is also fine, I guess. Here it's fine. And if you are there, kindly just give me a response. Yes. So the point is, somebody has asked a request that, ma'am, can you please prove v minus v naught equals to 2ax using graph? So might be difficult in this session because we have planned this session for NEET, but I don't want you to disappoint. I can suggest you that if you go if you check in the playlist, okay, in the Vedantu Karnataka channel, go to playlist and there uh, go to first PUC. Okay, there's a playlist named as first PUC PCB. Check there I have done multiple times. Okay, in the one shot revision of motion in a motion in a straight line, there I have done. And in discussing 3 marks and 5 mark question, practice question discussion also we did. Okay, all of them are available in the playlist first PUC PCB. Okay, go to live or go to playlist and check there, you will get it. Okay, it's there. Will you do that, Janani? We had done there with the graphical method, calculus method, everything is done there. Can you check there? Yes. Hope you will try doing that. It's there. Okay. Hope that is fine. And later also, when it comes to motion in a straight line, we can have a quick recall of this graphical method of deriving the equation. That is also fine. Okay, I think I'll continue with the session from this point. Hope the information I gave you is useful for you. I hope so. Okay. Yes. So going ahead with the questions. Trace the dimensional constant. So we are now moving to MCQs. First question or first MCQ for the day. Trace the dimensional constant. So ಇಲ್ಲಿ 4 ಆಪ್ಷನ್ ಇದೆ, ಅದರಲ್ಲಿ ಯಾವುದು ಡೈಮೆನ್ಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಐ ಆಲ್ರೆಡಿ ಟೋಲ್ಡ್ ಯು ಏನು in the case of dimensions, there can be some physical quantities, okay, so which are going to have dimensions. Okay, physical quantities or a constant, they can be a dimensional constant, dimensionless constant. Okay, so two types of possibilities are there. So ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಯೂನಿವರ್ಸಲ್ ಗ್ರಾವಿಟೇಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಇದೆ. Okay, universal gravitational constant, which is usually represented by capital G. So idu nimge, if you are in class 12, you know this. If you are in class 11, nimge gravitation chapter baratte, Newton's law of gravitation anta. So alli the force, the gravitational force of attraction between two mass, we give it by F is equals to G m1 m2 by r square anta barittivi. Okay, so from here we can clearly see that this G is going to have the dimension of fr square by m square anta baritini. Okay, dimension notation al bardiradu nanu. So the gravitational constant is going to have the dimension of fr square by m square. So try it out. Okay, try to get the dimension of gravitational constant, but it is definitely going to have a dimension. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಿದೆ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ಅನ್ ಐಸೋಟ್ರೋಪಿಕ್ ಮೀಡಿಯಂ ಅಂತಿದೆ. ಸೊ ಇದು ಸ್ನೆಲ್ಸ್ ಲಾ ಯೂಸ್ ಮಾಡಿ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. ನೀವು 10th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅಲ್ಲ 9th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಅಲ್ಲ ರೇ ಆಪ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ಆಪ್ಟಿಕ್ಸ್ ಚಾಪ್ಟರ್ ಇದ್ರೆ ಯು ಮೈಟ್ ಹ್ಯಾವ್ ಡಿಫೈನ್ಡ್ ಇಟ್, ರೈಟ್? ಸೊ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ಗಿವನ್ ಮೀಡಿಯಂ ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡ್ತೀರಾ? n is equals to sin I by sin r ಅಂತ ಬರಿತೀರಿ, ಕರೆಕ್ಟ್? ಯಾ. ಸೊ ದ ರೇಷಿಯೋ ಆಫ್ ದಿ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಅಂದ್ರೆ ಏನು? ದಿಸ್ ಇಸ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ದ ಡೈಮೆನ್ಷನ್. ಸೊ ಏನಾಗಿರುತ್ತೆ, ಇದಕ್ಕೆ ನೋ ಡೈಮೆನ್ಷನ್. ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ಗೆ ಡೈಮೆನ್ಷನ್ ಇರಲ್ಲ. ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಡಿಫೈನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಇನ್ ದಿ ಮೀಡಿಯಂ ಟು ದಿ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಇನ್ ದಿ ವ್ಯಾಕ್ಯೂಮ್. ಐ ಮೀನ್ ವ್ಯಾಕ್ಯೂಮ್ ಟು ದಿ ಮೀಡಿಯಂ ತರನು ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ಪೀಡ್ ಆಫ್ ಲೈಟ್ ಅಲ್ಲೂ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ನೆಲ್ಸ್ ಲಾ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ sin I by sin r ಅಂತಾನೂ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು, ವಿಚ್ ವಿಲ್ ಗಿವ್ ಯು ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್. ಸೊ ಇಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಅ ಡೈಮೆನ್ಷನ್ ಲೆಸ್. ನೆಕ್ಸ್ಟ್ ಏನಿದೆ, ಸ್ಪೆಸಿಫಿಕ್ ಗ್ರಾವಿಟಿ ಅಂತಿದೆ. ಓಕೆ, ಸ್ಪೆಸಿಫಿಕ್ ಗ್ರಾವಿಟಿ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ದಿ ಡೆನ್ಸಿಟಿ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಟು ದಿ ಡೆನ್ಸಿಟಿ ಆಫ್ ವಾಟರ್. ಓಕೆ, ಸೊ ಸ್ಪೆಸಿಫಿಕ್ ಗ್ರಾವಿಟಿ ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, ರೇಷಿಯೋ ಆಫ್ ದಿ ಡೆನ್ಸಿಟಿ ಆಗಿರುತ್ತೆ. ಅಗೇನ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾವ್ ದ ಡೈಮೆನ್ಷನ್. ಓಕೆ, ಸೊ ಅದಕ್ಕೂ ಡೈಮೆನ್ಷನ್ ಇರಲ್ಲ. ರೇಷಿಯೋ ಆಫ್ ಸೇಮ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ, ಆ ಪಾಯಿಂಟ್ ಬರ್ಕೊಂಬಿಡಿ. ಸೊ ಫಾರ್ ರೇಷಿಯೋ ಆಫ್ ಸೇಮ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ, ಅದಕ್ಕೇನು ಡೈಮೆನ್ಷನ್ ಇರಲ್ಲ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ರಿಲೇಟಿವ್ ಪರ್ಮಿಟಿವಿಟಿ ಅಂತ ಇದೆ. ಸೊ ಇದು ನಿಮ್ಗೆ ಸೆಕೆಂಡ್ PUC ಅಲ್ಲಿ ಬರುತ್ತೆ. ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡ್ತೀರಾ? ರಿಲೇಟಿವ್ ಪರ್ಮಿಟಿವಿಟಿ, ವಿಚ್ ವಿ ಯೂಶಲಿ ರೈಟ್ ಇಟ್ ಆಸ್ ದಿ ನೊಟೇಷನ್ K. ಇಟ್ ಇಸ್ ದಿ ಪರ್ಮಿಟಿವಿಟಿ ಆಫ್ ದಿ ಮೀಡಿಯಂ ಟು ದಿ ಪರ್ಮಿಟಿವಿಟಿ ಆಫ್ ದಿ ಫ್ರೀ ಸ್ಪೇಸ್ ಅಂತ ಬರಿತೀವಿ. ಓಕೆ, ರೇಷಿಯೋ ಆಫ್ ಪರ್ಮಿಟಿವಿಟಿ ಆಫ್ ಎ ಮೀಡಿಯಂ. ಪರ್ಮಿಟಿವಿಟಿ ಅಂದ್ರೆ ಅದು ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ನಿಮ್ಗೆ. ಏನಾಗಿರುತ್ತೆ, ಹೌ ದ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ವಿಲ್ ಇಂಟ್ರಾಕ್ಟ್ ಇನ್ ಎ ಗಿವನ್ ಮೀಡಿಯಂ. ಓಕೆ, ಆರ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಹೆಂಗಿರುತ್ತೆ ಫ್ರಮ್ ಮೀಡಿಯಂ ಟು ಮೀಡಿಯಂ, that is decided by, I mean, electrostatic field. Okay, so that is decided by this permittivity term. So ಏನು ಹೇಳ್ಬೋದು, the ratio of the permittivity of a given medium, ಯಾವುದೇ ಕೊಟ್ಟಿರೋ ಮೀಡಿಯಂಗೂ, to the relative permittivity, I mean to the permittivity of free space or vacuum. Okay, this epsilon naught is permittivity of free space or vacuum. ರೇಷಿಯೋ ಆಫ್ ಸೇಮ್ ಕ್ವಾಂಟಿಟಿನೇ ಆಗುತ್ತೆ ಅಲ್ವಾಗ. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ನಾಟ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾವ್ ಡೈಮೆನ್ಷನ್, ನೋ ಡೈಮೆನ್ಷನ್. ಸೊ ನಮಗೆ ಡೈಮೆನ್ಷನಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಬೇಕು. ದಟ್ ಈಸ್ ಆಪ್ಷನ್ 1 is the correct answer. Okay, hope it is clear. Yeah, so I just want to put this separately. Yeah, hope it is clear. I think we can move ahead to next question quickly. That is, if U1 and U2 are the units selected in two systems of unit of any physical quantity and N1 N2 are their numerical value, then ಯಾವ representation correct ಅಂತ ಕೇಳಿದ್ದಾರೆ. So we know that any physical quantity is given by NU and ಎರಡು system of unit ಇದ್ರೆ ಹೆಂಗಿರುತ್ತೆ, N1 U1 is equals to N2 U2 ನೇ ಆಗಿರುತ್ತೆ. Okay, where N1 and N2 represents their numerical value, U1 U2 corresponds to their units. Okay, any doubt? If any doubt, please feel free to ask in the chat box. So we'll move on to next question. Pressure P is equals to alpha minus T square by beta L, where T is time and L is distance. Then dimension of alpha by beta kelidare. So this is one type of question. So we'll just quickly learn it. So ಇದೇ ತರ ಎಷ್ಟು ಕ್ವೆಶ್ಚನ್ ಬೇಕಾದ್ರೂ ಫ್ರೇಮ್ ಮಾಡಬಹುದು. So idu one standard method na you can practice. So let me just divide. Okay, so ಏನಿದೆ ಅಲ್ಲಿ pressure P is equals to alpha minus t square by beta L ಅಂತಿದೆ. ಓಕೆ, ಸೊ ಇದನ್ನ ನಾನು ಸ್ವಲ್ಪ ರೀಅರೇಂಜ್ ಮಾಡ್ತೀನಿ. P ಇಂಟು ಬೀಟಾ ಎಲ್ ಏನು ಬರಿಬೋದು? P ಇಂಟು ಬೀಟಾ ಎಲ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಆಲ್ಫಾ ಮೈನಸ್ ಟಿ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರಿಬೋದು. ಕರೆಕ್ಟ್? ಸೊ ಇದನ್ನ ಈಗ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜೆನಿಟಿ ಅಪ್ಲೈ ಮಾಡೋಣ. ಸೊ ಫ್ರಮ್ ದಟ್ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಕ್ಲಿಯರ್ಲಿ ಟೆಲ್, ಸೊ ಎನಿ ಟರ್ಮ್ಸ್ ವಿಚ್ ಆರ್ ಸಪರೇಟೆಡ್ ವಿತ್ ಪ್ಲಸ್ ಮೈನಸ್ ಆರ್ ಈಕ್ವಲ್ಸ್ ಇದ್ರೆ ಏನಾಗಿರುತ್ತೆ, ಅದರ ಡೈಮೆನ್ಷನ್ ಸೇಮ್ ಇರುತ್ತೆ. ಕರೆಕ್ಟ್? ಸೊ ಈಗ ಏನು ಹೇಳ್ಬೋದು, ದ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಆಲ್ಫಾ ವಿಲ್ ಬಿ ಸೇಮ್ ಆಸ್ ದಿ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಟಿ ಸ್ಕ್ವೇರ್. ಸೊ ದಟ್ಸ್ ಅ ವೆರಿ ಸಿಂಪಲ್ ಫ್ಯಾಕ್ಟ್, ಸೊ ವಿಚ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಡೌನ್. ಸೊ ಏನು ಹೇಳ್ಬೋದು ನಾನು, ದ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಆಲ್ಫಾ will be equal to the dimension of t square, or alpha ಅಂದ್ರೆ ಹೆಂಗ್ ಬರೀತೀವಿ, ಐ ಮೀನ್ t square ನ ಹೆಂಗ್ ಬರಿಬೋದು ಡೈಮೆನ್ಷನಲ್ ನೋಟೇಷನ್ ಅಲ್ಲಿ m0 l0 t power 2 ಅಂತ ಬರಿಬೋದು. yes or no? If you are following, just respond there. yes. ಸೊ ಏನು ಹೇಳ್ಬೋದು, the dimension of alpha will be equal to the dimension of t square because the terms are separated by a minus sign here. Correct? So we can add or subtract the quantities which are having the same dimension ಆಗಿರೋದ್ರಿಂದ we can clearly tell that the dimension of alpha will be same as the dimension of t square. Next ಇನ್ನೊಂದು ಸ್ಟೆಪ್ ಏನು ಹೇಳ್ಬೋದು, the dimension of p beta l will be equal to the dimension of t square ಅಂತಾನೂ ಹೇಳ್ಬೋದು. ಕರೆಕ್ಟ್? ಸೊ ಈ ಮೂರು ಟರ್ಮಿನ ಡೈಮೆನ್ಷನ್ ಶುಡ್ ಬಿ ಸೇಮ್ ಆಸ್ ದಿ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಆಲ್ಫಾ, ಶುಡ್ ಬಿ ಸೇಮ್ ಆಸ್ ದಿ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಟಿ ಸ್ಕ್ವೇರ್ ಆಗಿರುತ್ತೆ. ಕರೆಕ್ಟ್? ದಟ್ ಇಸ್ ಅಗೈನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜೆನಿಟಿ. ಸೊ ನಮಗೆ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಬೀಟಾ ಬೇಕು, ಸೊ ಐ ಜಸ್ಟ್ ರೀಅರೇಂಜ್ ದಿಸ್. ಡೈಮೆನ್ಷನ್ ಆಫ್ ಬೀಟಾ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಡೈಮೆನ್ಷನ್ ಆಫ್ ಟಿ ಸ್ಕ್ವೇರ್ divided by the dimension of p into l. Okay, so I'll just write in the next page so that you can see that. So ಏನಾಗಿರುತ್ತೆ, dimension of beta will be equal to the dimension of t square ಅಂತಿದೆ, so that is m0 l0 t square. okay, so ಏನಿದೆ ಅಲ್ಲಿ m0 l0 t square ಆಗುತ್ತೆ, t square by pl ಅಂತ ಇದೆ, that is the dimension of pressure. so pressure in a dimension ಹೆಂಗ್ find out ಮಾಡ್ಬೋದು? yes, so pressure in a dimension ಹೆಂಗ್ find out ಮಾಡ್ಬೋದು? so pressure ಹೆಂಗ್ ಬರೀತೀರಾ? force by area. correct? so the dimension of pressure is force by area dimension ಆಗಿರುತ್ತೆ. force ಅಂದ್ರೆ ml t minus 2 by l square, or this will give you the dimension of pressure as m l raised to 1 minus 2 andre l raised to minus 1 and t power minus 2. so illi substitute ಮಾಡೋಣ. and the dimension of l anta ide, so ಹೆಂಗ್ ಬರಿಬೋದು, dimension of beta is equals to m0 l0 t square whole divided by m l raised to minus 1 t raised to minus 2 into the dimension of length ಇದೆ ಇಲ್ಲಿ, so ಅದನ್ನ ಬಿಡಬೇಡಿ, so into l ಆಗುತ್ತೆ. okay, so this l minus 1, this l plus 1 will go away, so remaining terms ಅನ್ನ ಬರೀರಿ. beta is equals to, so ಇದು ನ್ಯೂಮರೇಟರ್ಗೆ ಹೋದ್ರೆ m raised to minus 1, ಇಲ್ಲಿ m power 0 ಇದೆ. correct? and then l raised to 0 ನೇ ಆಗುತ್ತೆ. correct? and then t power 2 ಇದೆ, ಇಲ್ಲಿ minus 2 ಇದೆ, ಮೇಲೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ, t power plus 2 ಆಗುತ್ತೆ, so t power 2 plus 2 which will give us t power 4. ಈಗ ನಮ್ಗೆ ಏನು ಬೇಕು, the ratio of dimension of alpha to the dimension of beta ಕೇಳಿರೋದು. okay, the dimension of alpha by the dimension of beta. so dimension of alpha ಏನು ಬಂದಿತ್ತು ನಮಗೆ, m0 l0 t square divided by beta dimension ಏನು ಬಂದಿದೆ m-1 L0 t ಪವರ್ 4 ಅಂತ ಬಂದಿದೆ. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಸೊ ಏನು ಬರುತ್ತೆ ನಮಗೆ m ರೈಸ್ ಟು 1 ಆಗುತ್ತೆ, ಇದು ನ್ಯೂಮರೇಟರ್ಗೆ ಹೋದ್ರೆ. ಓಕೆ, L ಪವರ್ 0 t ಪವರ್ -2 ಆಗುತ್ತೆ. ಸೊ ಲೆಟ್ ಮಿ ರೈಟ್ ಹಿಯರ್, ಯು ಕಾಂಟ್ ಸಿ ದೇರ್. ಸೊ ಏನು m L0 t ಪವರ್ -2. ಓಕೆ, m L0 t ಪವರ್ -2. Okay, so that is, yeah, option 3 is the correct answer. Okay, so m raised to 1 L raised to 0 t power -2. Yes, any doubts you can quickly ask there, or we'll just move on to the next question. Yes, good evening Manju, I think you just have joined now. Yeah, we have discussed sufficient enough theory part of the dimensions and applications of dimensions, and now we are moving to the MCQ part of dimensions. Okay, so if you haven't watched it, you can also watch it later. All these are freely available in YouTube, so you can watch at your own convenient time. Okay, hope it is fine. Yes, so next question. The dimensional formula of torque. So torque in a dimensional formula find out madak helidare. So torque heng baritivi, usually represent mado symbol tau. Okay, torque is force into perpendicular distance anta baritini. Later nimge adu exactly ಏನಂತ ಗೊತ್ತಾಗುತ್ತೆ. So force into perpendicular distance. In the vector notation baradre torque tau vector is equals to r cross f anta bardirtivi. Okay, so torque in a dimension bekandre force into perpendicular distance in a dimension baribeku. So force in a dimension enu m L t -2, perpendicular distance in a dimension andre enu distance alva, so it is just L or m0 L t0 antanu baribodu. Okay, m0 L raised to 1 t0, which will give you torque as m L square t -2. Okay, m L square t -2, that is option 1 is the correct answer. Okay, yes Manju, are you there? Hope you are following now. Yes, any doubts? If no doubts, we'll just move ahead to the next question. Yes, here is the next question. Temperature can be expressed as a derived quantity in terms of. So temperature na, how can we express in terms of some derived quantity anta kelidare. Agatta, what is this temperature? Temperature is a fundamental quantity or a base quantity, correct? You can say like fundamental quantity. You know, temperature is fundamental quantity or base quantity. So adanna ನಾವು ಬೇರೆ ಯಾವುದೇ ಕ್ವಾಂಟಿಟಿಯಲ್ಲೂ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. It cannot be expressed in terms of any derived quantity or any other fundamental quantity. So length mass allo bariyakagalla, mass time allo bariyakagalla, length mass time allo agalla, because temperature itself is a fundamental quantity in our SI system. So option 4, none of this is the correct answer. Okay, hope it is clear. It's a very simple question. I think we can go ahead to the next question, that is, in the CGS system of units, the magnitude of the force is 100 dyne. If in another system of units, the fundamental physical quantities like mass, length, time are expressed in kilogram, meter and minute respectively, the magnitude of force in that system of unit is. ಸೊ ಇಲ್ಲಿ ಎರಡು ಯೂನಿಟ್ ಇದೆ. ಒಂದ್ ಯಾವುದು ಸಮ್ ಸಿಜಿಎಸ್ ಯೂನಿಟ್ ನಮಗೆ ಗೊತ್ತಿದೆ, ಸಿಜಿಎಸ್ ಸಿಸ್ಟಮ್ ನಂಗೆ ಗೊತ್ತಿದೆ, ಅದರಲ್ಲಿ ಫೋರ್ಸ್ ನ ಡೈನ್ ಇಂದ ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ಅಂಡ್ ಇಲ್ಲಿ ಎಷ್ಟು ಫೋರ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ, 100 ಡೈನ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಇದಕ್ಕೆ ಇನ್ನೊಂದು ನ್ಯೂ ಸಿಸ್ಟಮ್ ಆಫ್ ಯೂನಿಟ್ ಅಲ್ಲಿ ಈಕ್ವಿವೆಲೆಂಟ್ ಏನಿರತ್ತೆ ಅಂತ ಕೇಳಿದರೆ, ಆ ನ್ಯೂ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಏನಿದೆ, ಮಾಸ್ ನ ಕೆಜಿಲ್ ಮೆಷರ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಲೆಂತ್ ಇಸ್ ಮೆಷರ್ಡ್ ಇನ್ ಮೀಟರ್, ಬಟ್ ಟೈಮ್ ಈಸ್ ಮೆಷರ್ಡ್ ಇನ್ ಮಿನಿಟ್ ಇದೆ. ಸೊ ಇದಕ್ಕೇನು ಒಂದೇ ಫಾರ್ಮುಲಾ, n1 u1 is equals to n2 u2, or I can write n2 is equals to n1 u1 by u2 ಅಂತ ಬರೀಬಹುದು. So where this u1 and u2 are the dimensions of the unit in the given to reference, correct? So ಇಲ್ಲಿ ಏನು ಹೇಳ್ಬೋದು, n1 is equals to 100. Do you agree? So n1 ಅಂದ್ರೆ 100, u1 ಅಂದ್ರೆ ಸಿಜಿಎಸ್ ಅಂದ್ರೆ ಯಾವ್ದಿಲ್ಲಿ ಡೈನ್, n2 ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. u2 is our new system. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಇದು ಯಾವ ಕ್ವಾಂಟಿಟಿ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇರೋದು, ಫೋರ್ಸ್. ಸೊ ಏನ್ ಮಾಡ್ತೀರಾ, ಫೋರ್ಸ್ ಇನ ಡೈಮೆನ್ಷನ್ ಬರೀರಿ. ಓಕೆ, ಸೊ ಫೋರ್ಸ್ ಇಸ್ ಮಾಸ್ ಇಂಟು ಆಕ್ಸಿಲರೇಷನ್, ಸೊ mlt minus 2. ಈಗ ಆ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಬರೀರಿ, ಏನ್ ಬರಿಬಹುದು, n2 is equals to, so n1 ಅಂದ್ರೆ 100, u1 ಅಂದ್ರೆ m1 l1 t1 raised to minus 2. That is the basic unit of mass, length, time in the first system to the u2 andre en baribodu m2 l2 t2 raised to minus 2. Okay, hope you are following. If you are following, just give me a thumbs up in the chat box or respond in the chat box. Okay, so now we'll just substitute with their proper units. So let me just add a page here. So n2 is equals to 100, m1 mass is measured in, so we are talking about which system of unit, CGS illi u1 is our CGS unit, right? So u1 yaudide CGS, SI alla. So mass is measured in grams, length is measured in centimeter, and second minus 2. Hope you agree. Yeah, mass andre gram, length andre centimeter, t1 raised to power minus 2 ಇದೆ, so second minus 2 ಆಗುತ್ತೆ. ಅದೇ ತರ ಸೆಕೆಂಡ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ u2 ಗೆ ಏನ್ ಬರೀಬಹುದು, ಸೊ ಅಲ್ಲಿ ಮಾಸ್ ಇಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಕಿಲೋಗ್ರಾಮ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇಫ್ ಯು ಅಬ್ಸರ್ವ್. ಓಕೆ, ಲೆಂತ್ ಇಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಮೀಟರ್ ಇದೆ, ಅಂಡ್ ಟೈಮ್ ಇಸ್ ಮೆಜರ್ಡ್ ಇನ್ ಮಿನಿಟ್, ಕರೆಕ್ಟ್? ಸೊ ಕೆಜಿ, ಮೀಟರ್, ಮಿನಿಟ್ minus 2 ಅಂತ ಬರೀಬಹುದು. ಓಕೆ, ಸೊ ನಿಮಗೆ ಡೀಟೇಲ್ ಆಗಿ ಅರ್ಥ ಆಗ್ಲಿ ಅಂತ ಸ್ಟೆಪ್ ವೈಸ್ ಬರೀತಾ ಇದ್ದೀನಿ, ಬಟ್ ನೀವು ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಆಫ್ಟರ್ ಸಮ್ ಪ್ರಾಕ್ಟೀಸ್ ಯು ಶುಡ್ ಬಿ ಕ್ವಿಕ್ ಎನಫ್ ಟು ಸ್ಕಿಪ್ ಸಮ್ ಸ್ಟೆಪ್ಸ್ ಅಂಡ್ ಟು ಡೂ ಇಟ್ ಇನ್ ಎ ಫಾಸ್ಟ್ ವೇ. ಓಕೆ, n2 is 100 into gram, centimeter, second minus 2 I'll keep as it is, divided by ಇಲ್ಲಿ kg ಅಂತ ಇದೆ, ಅಂದ್ರೆ ಏನ್ ಬರೀಬಹುದು, 1000 grams. You can write like 10 power 3 grams, correct? Hope you agree. Meter andre enu 10 power 2 centimeter anta baribodu. Okay, and next il enide minute minus 2 antide. Minute andre 1 minute is 60 second, correct? 60 second minus 2 ಆಗುತ್ತೆ. ಈಗ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ, ಸೊ 100, ಸೊ ಏನೇನು ಲೈಕ್ ಟರ್ಮ್ಸ್ ಇದೆಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಗ್ರಾಮ್, ದಿಸ್ ಸೆಂಟಿಮೀಟರ್, ಸೆಕೆಂಡ್ ಮೈನಸ್ 2 ಹೋಗುತ್ತೆ. ರಿಮೈನಿಂಗ್ ಟರ್ಮ್ಸ್ ಬರೆದ್ರೆ 100 ಇಂಟು, ಸೊ ನ್ಯೂಮರೇಟರ್ ಏನೂ ಇಲ್ಲ. ಓಕೆ, 100 ಡಿವೈಡೆಡ್ ಬೈ ಬರೆದು ಬಿಡ್ತೀನಿ ಡೈರೆಕ್ಟ್ ಆಗಿ. ಸೊ 100 ಡಿವೈಡೆಡ್ ಬೈ 10 power 3 into 10 power 2. ಇಲ್ಲಿ 60 second minus 2 ಇದೆ, so that I can write in the numerator as 60 into 60, correct? So this is like 60 raised to power minus 2, which will go to numerator as 60 power plus 2. So that can be written as 60 into 60. Okay, so illi 100 and 10 power 2 will go away. So in remaining terms uliyutte nodi. So il 1 0 and 10 power 3 ide, alli 10 power 2 hogutte. So just you get something like 36 divided by 10, which is going to give you 3.6. Okay, so enagatte 3.6 is the new value in the, the numerical value in the new system of unit. So that is option 3 is the correct answer. Okay, hope it is clear. Any doubt? Feel free to ask in the chat box. Any doubts? Okay, I think no doubts there. We can just go ahead. So similar to the previous question idu vandu, I want you to take it as a homework. Okay, so alli force in the unit ittu, illi yavudide density kottidare. So you can take n1 as 128 kg per meter cube ide. So unit 1 yavud idralli SI system e tagondbidi, adara dimension bariri. Dimension of density nu kottbidtini, mass by volume. So mass by volume andre ml raised to minus 3 agutte. And new system alli length is measured as 25 centimeter, mass is measured as 50 gram ide. So alli numerical value andre n2 ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಓಕೆ, ಯಾ, ಸೊ ಇಲ್ಲಿ ಏನು ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ, ಡೆನ್ಸಿಟಿ ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಿರಬೇಕು. ಡೆನ್ಸಿಟಿ ಇಸ್ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್. ಸೊ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಡೆನ್ಸಿಟಿ, ಸೊ ಡೆನ್ಸಿಟಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದು ರೋ ಸಿಂಬಲ್ ಇಂದ. ಓಕೆ, ಸೊ ml minus 3 ಆಗಿರುತ್ತೆ. Okay, so with this you please try it as a homework, very similar to this previous question. You can quickly do it. Okay, so now we will move on to something called as significant figures. Okay, so any doubts please ask in the chat box. I'm not getting any response as of now, so it will be good if you respond in the chat box. Can you just kindly respond so that you can go ahead? Okay, yes, so that is the next concept yavudide, significant figures. Okay, units and measurement alli so 4 basic topic anta divide ಮಾಡಬಹುದು. ಒಂದು unit, next is dimensions and its application, next is significant figures, and then comes is the errors. Okay, so our 4 topic wise ನೀವು ಓದ್ತಾ ಹೋಗಿದ್ರೆ ಈಸಿ ಆಗುತ್ತೆ. So now we are already done with 2, so we are moving to significant figures, and in the next class we will be doing with the something called as errors and propagation of errors. Okay, yeah, so what are significant figures? So significant figure andre, so ಯಾವುದೋ ಒಂದು ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ತೀವಿ. Okay, in any experiment, might be a simple experiment like measuring a length, measuring the height, depth, whatever you do in your labs, some simple measurement ಮಾಡ್ತೀರಾ. ಸೊ ಆ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಿ ಫೈನಲ್ ರಿಸಲ್ಟ್ ಬರಿಬೇಕಾರೆ, ಓಕೆ, ಸೊ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, some digits are 100%, we know it is correct, that we call it as reliable digit. Okay, reliable digit plus the first uncertain digit. So last digit in your measurement is not certain, it is uncertain. We don't know whether it is exactly correct or not. Okay, so adashtunu ಸೇರಿಸಿ ನಾವು significant figures ಅಂತ ಕರಿತೀವಿ. Reliable digit plus the first uncertain digit. Okay, for example, ಯಾವುದೋ ಒಂದು some wooden bar ಕೊಟ್ಟಿದ್ದಾರೆ ಅನ್ಕೊಳ್ಳಿ, we had to measure its length. Okay, using the normal meter scale. ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, ಲೆಂತ್ ಮೆಜರ್ಮೆಂಟ್ ಯೂಸಿಂಗ್ ನಾರ್ಮಲ್ ಮೀಟರ್ ಸ್ಕೇಲ್ ಮಾಡಿದೀವಿ. ಸೊ ಮೆಜರ್ ಮಾಡಿದ್ರೆ ಲೆಟ್ ಅಸ್ ಸೇ ದ ರೀಡಿಂಗ್ ಇಸ್ ಬಿಟ್ವೀನ್ 3.1 to 3.2 ಬಂದಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಓಕೆ, ಆರ್ ಇದನ್ನ ಮೆಜರ್ ಮಾಡಿದೀವಿ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಸಮ್ವೇರ್ ಅರೌಂಡ್ 15 ಸೆಂಟಿಮೀಟರ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಓಕೆ. ಸೊ 15.5 ಇಂದ 15.6 ಮಧ್ಯದಲ್ಲೆಲ್ಲೋ ಇದೆ. ಸೊ ಆಗೇನು ಐ ಕ್ಯಾನ್ ಕ್ಲಿಯರ್ಲಿ ಟೆಲ್ ದ್ಯಾಟ್ ಓಕೆ. ಸೊ ಆ 15.5 ಟು 15.6 ಅಂದ್ರೆ ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಎರಡು ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿದೆ. ದಿಸ್ 15 ಇಸ್ ದಿ ರಿಲಯಬಲ್ ಡಿಜಿಟ್. ಐ ನೋ ಇಟ್ ಅಕ್ಯುರೇಟ್ಲಿ 15 ಹೌದು, ಬಟ್ ಈ 0.5 ಇದೆಯಲ್ಲ ಆರ್ ದಿ 6 ಅವೆರಡರ ಮಧ್ಯೆ ಇರೋದ್ರಿಂದ ಐ ಕಾಲ್ ದಿಸ್ ಆಸ್ ಅನ್ಸರ್ಟೈನ್. ಓಕೆ. ಸೊ ಏನದು? ದಟ್ ಈಸ್ ದಿ ಅನ್ಸರ್ಟೈನ್ ಡಿಜಿಟ್. ಓಕೆ. ಸೊ ಇಲ್ಲೂ ಹಂಗೆ ಆಗತ್ತೆ. ದಿಸ್ 3 ಐ ನೋ the given wooden bar is of some length something greater than 3 or something greater than 3.1 or less than 3.2 ಅದು ನಂಗೆ ಗೊತ್ತಿದೆ. ಆ ಮಧ್ಯದ 3.12 ಆಗಿರ್ಬೋದು, 13 ಆಗಿರ್ಬೋದು, ಓಕೆ, 3.15 ಆಗಿರ್ಬೋದು, that is uncertain. So this is the first uncertain digit, correct? Okay, but this is a reliable digit. So the reliable digits, all the reliable digits plus the first uncertain digit. First uncertain digit we call it as significant figures. So illenagirutte, if I say 3.1, okay, so ee 3.1 alli two significant figures irutte. Okay, that is 3 and 1. Ade tara 15.5 tagondre so enagirutte, so 1, 2, 3. So this is going to have 3 significant figures. Okay, is that clear? So that is going to have 3 significant figures. Okay, is that fine? So now, so this is the basic of significant figures. Yade one measurement madi. Okay, so we have to give importance to the significant figures and we express the digits up to the measure significant figure. So this will tell you about the accuracy of your measurement. Okay, so all the digits that are known properly plus the first uncertain digit, we call it as significant figures. Okay, so ಇಲ್ಲಿ ಎರಡು basic rule ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. If you are yes Rajesh, for now you don't worry if you are late and if you have missed it, because anyway it's always available in YouTube. So go to the proper playlist or check in the live session of Vedantu Karnataka. So yav subject ina yav class bekadru available irutte. Okay, they are always available in YouTube. Okay, you can follow it later. Yeah, listen to a little bit of theory and then go for the MCQs which are discussed. Okay, whenever you are late, please do that. Smart board for now it is difficult. Let's see in future. Okay, because I'm in a different place for now, so in future we can think of that. Okay, yeah. So hope you will listen to the sessions that are discussed till now later when you're free, and hope it will helpful for your preparation for NEET of this chapter. Okay, I hope so. Yes Rajesh. Okay, so next with respect to the significant figures, okay, the number of significant figures will tell you about the precision of measurement. ಎಷ್ಟು ಪ್ರಿಸೈಸ್ ಆಗಿ ಒಂದು ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಿದೀವಿ, so that we will get from knowing the significant figures. And there is one basic thumb rule which we had to follow, that is with respect to the choice of change of different units, do not change the number of significant figures in a measurement. Significant digits antanu helbodu, significant figures antanu helbodu. So if I am expressing meter to centimeter, some length, okay, millimeter, atara units na change madidru the number of significant figures change agbardu. So we have to keep that in our mind and we have to set up the rules to get the significant figures. And also, or something like kg to gram to microgram or kilogram, like that. Okay, if I change the unit, it should not to change the number of significant figures in the measurement. So adanna ನಾವು ಇಟ್ಕೊಂಡು ಸರ್ಟೈನ್ ರೂಲ್ಸ್ ಇದೆ. ಓಕೆ, ಸೊ ಅದನ್ನ ಐ ಥಿಂಕ್ ದ ಟೈಮ್ ಈಸ್ ಆಲ್ಮೋಸ್ಟ್ ಡನ್. ಸೊ ದಿಸ್ ಪಾರ್ಟ್ I will discuss in the next session. Okay, how to represent the significant figure and how to do the addition and subtraction with the significant figures. And then we also have certain problems or MCQs to discuss on the significant figures, which I would like to discuss in the next session, because we are almost running out with the time. Okay, so the rules of the significant figures and the problems on significant figures I am going to discuss in the next session. So here I just want you to quickly tell you about the most awaited scholarship exam, that is MVSAT. Okay, Mega Vedantu Scholarship Admission Test. Many of you might be waiting for this. So the dates are announced, the offline test dates, which are going to be on 4th, 5th, 11th and 12th of October. So you can take this test in the nearby Vedantu offline centers. So Vedantu center, one is at JP Nagar, second phase, which you can go there, and first you have to register yourself and then you can take this test, and the registration link will be provided in the description of all the lectures that are going on every day now. So you can check in the description box to register yourself for MVSAT. Okay, and hence thereby you can get a cash prize, or might be a laptop, or might be some electronic gadgets which are helpful for your online preparation for any exams, depending on which standard you are studying. Okay, and also you will get an access to free online courses. Okay, yeah, and study materials will also be provided by clearing the MVSAT exam. Okay, hope most of you will take up this test. Give it your best. Yes, I hope you will be taking up this. Okay, so exam center, for now it is offline, and you can visit to our Vedantu offline centers. Okay, yes, with this I would like to conclude today's session. If any doubts are still there with respect to MVSAT exam or with respect to the topics that are discussed now, feel free to ask in the chat box. Okay, if no doubts, we'll just straight away end the session now. Okay, thank you all.